Labrīt. Good morning, everybody. Can you hear me well? The sound is a bit strange, but let's hope it works. My name is Oscar. I'm going to be the moderator of today, which, according to what I see in the agenda, means that I'm going to be the bad guy, telling you always you have to stop, in time, and because, well, to be honest, I've never seen such a schedule in my life. 35 pitches in a single day. It's quite a lot. But on the other hand, I think it's a good opportunity for the Space Industry Day and for all the stakeholders, both the large system integrators and the potential vendors and everybody in this room. Today, the spring has officially started. Astronomically, I guess that's the name they use. And what we do is we hide in the basement, it's because there's sun out there, so we have to, be careful not to get sunburned, I believe. But anyway, just to emphasize the importance of this day and encourage you to find some inner and outer energies to sustain the tight schedule that we have today. So as you know, this event is organized by several counterparts, including, of course, European Space Agency, and then the Ministry of Education and Science in Latvia, and the Ministries for Economics in Lithuania and Estonia. So, my dear Estonians, where are you? Can I see you? Can you raise your hands? All right, you've spread your strategic placement. Lithuanians? Labas rytas? Whoa, so many. It's like an invasion here. Latvians? Any? Okay, good. We have some imbalance between Estonia, Latvia, and Lithuania, but well, you can see it on a map as well, so it's a logical thing that we have here. Good. What else? We have live streamed, and we are live streaming this event on all different media, CNN, BBC, and stuff like that. So, while the whole world sees us, to be more serious, it's more or less social media, and of course, the ministries. Latvian Ministries of Education and Science webpage that they can see us. So good morning to you guys at your computer screens and mobile devices. Good. What else? Well, official openings, a few of those, and then of course presentations by large system integrators. So I'm asking to open this event and officially representing the Latvian national delegation by the State Secretary of the Ministry of Education and Science in Latvia, Liga, Lejina.
Morning. Thank you, Oscars, for a very inspiring introduction, especially of the official opening part. And indeed, the spring equinox is there, so we can wake up for a different part of the year. So good morning, ladies and gentlemen, to each and every one of you. And indeed, on the behalf of Ministry of Education and Science, I'm really glad to welcome you here in Riga on this Space Industry Day. And for us, this is symbolic that it also takes place in the National Library of Latvia, because I think philosophically and from industrial point of view, this has been quite impressive industrial project in the last decade here in Latvia. A warm welcome to our neighbors from Estonia and Lithuania, and I think especially now understanding your presence here and the scope of the presence, we can see that there is a clear interest and commitment from your side in cooperation and interest in the space business. And also a warm welcome to the representatives from Airbus, Defense and Space, OHB and Thales Alenia Space, which are the backbone of large-scale space projects in Europe. And we understand that for these companies, the Baltic region might be less known, but I think there's a great potential to explore. We are happy to note that space is becoming ever more integrated in the economy and society, and space policy is becoming an important and increasingly recognized tool for the EU and around the world. We all have heard about the new space economy and the ESA Space 4.0 concept, which represents the evolution of the space sector into a new era. Recent studies show that space sector deeply integrates with many industries, domains such as bioeconomy, urban development, connectivity, security, and others. And of course, each of these domains face different challenges, but they can also be very helpfully addressed using the space data and instruments that are available to us. Baltic cooperation with the European Space Agency has been progressing. We know that Estonia has been a full-fledged ESA member since 2015 and investing around 2.6 million euros annually in space activities, and since 2010 has participated in more than 50 projects. Latvia and Lithuania, though, have been European cooperating states of the ESA since 2015, and we now are considering possibility of joining ESA as associate members in 2020. Here in Latvia, we definitely know that ESA is a world-class organization with capabilities and expertise to help grow our space industry to the highest standards and excellence of space products and services, and therefore for us the deep relations with ESA are really a cornerstone of our space policy, and we know that our aim indeed remains unchanged to become one day a full member of ESA, and we hope this is not a long road to get there. So in this setting, for us, the aims of today's Space Information Day have been to facilitate cooperation between scientific institutions and industry in the space sector, to introduce Airbus, Thales, Alenia Space, and OHB with Lithuanian, Estonian, and Latvian space industries' capabilities and capacity, and to enhance cooperation between the three Baltic states' space industries. So I hope with the long list of today's activities, there is time enough, and you manage to grasp all the bits that are of your interest. Of course, we also thank colleagues in ESA and the Lithuanian and Estonian delegations for assistance and opportunity that we could organize together this Space Industry Day. And I hope you have a productive day. We will have an opportunity to meet also tonight with a number of representatives to take things further. So wishing you all the best and success in keeping that time management, Oskars. Thank you.
Right, thank you. Right, so our next opening speaker would highlight the objectives of the day, and Gertrud Talvik is from the European Space Agency, responsible for the industrial policy. The floor is yours.
Thank you. Good morning from my side as well. I'm going to keep it really short. It's going to be a really long day, and the State Secretary already said a lot of the things I wanted to say anyway. So I'm representing the new Associate and Cooperating States section of European Space Agency. I'm here today with my colleagues Sergio Tabasco and Zachary Rowland. If you could stand up really quickly so everyone knows what you look like. Also from ESA, Sandra Vogt is here representing the SME office. First of all, I'm really glad to see a lot of you here today. As it was already said, it's a really good opportunity to foster the cooperation between the Baltic states. And I'm especially glad because the three big LSIs are here, Airbus, OHB, and Thales, and they really form the cornerstone of the space industry in Europe. And for a lot of you, it's the first time actually interacting with them, so I'm really glad you're seizing this opportunity today. Myself, Sergio, and Zachary will be available throughout the day. If you have any questions or issues with logistics, you all should have already received your B2B meeting schedules. And otherwise, of course, thank you, Kaspers and the Ministry of Education and Science, and Sergio for organizing this, and of course, Egle and Denise for supporting. So, wishing you a constructive day today.
Latvia, there were several months that they were building the government after the election, and the most common word they used was constructive. It was really funny because when two political parties met and they came out of the room, and journalists asked, "So how it went?" Constructive negotiations, and then another few months pass by, nothing happens. Hopefully that's not the case here. Hopefully that's not the case here. All right, so we'll finish the opening speeches with our guest from European Space Agency, Ms. Sandra Vogt. I hope I'm pronouncing this well. So the Small and Medium Enterprise Initiative.
Good morning, everyone. As mentioned before, my name is Sandra Vogt from the SME office, working at ESTEC at ISIS Technical Heart in the Netherlands. I would like to take this opportunity briefly to tell you a bit about the SME initiative, our SME policy, and how you, or those of you being SMEs, might benefit from our activities. So for those of you who don't know us, like Gertrud's team, we're part of the Directorate of Industry, Procurement and Legal Services, and we're mandated with implementing the SME policy that the agency has agreed on in 2016 in the Industrial Policy Committee by the member states. So the objectives of the policy are to facilitate the integration of SMEs in the activities of the agency, and those concern both technology activities as well as the development programs that we have. And the policy tackles issues that are traditionally faced by SMEs, such as sustainability, viability, access to in-flight heritage, and proper and timely information. Just to give you a quick overview of how the policy developed, at the beginning or at the end of the 1990s, the focus on SMEs started at that time more in the technology domain, and slowly but steadily it has also evolved in including development programs. So as you see, in 2016, we agreed to the SME policy as it stands today, which we are implementing, and in the Intermediate Ministerial Council, a resolution was passed, which also highlighted the importance of SMEs yet again. Just for those of you who might not be familiar with our SME definition and who we actually consider to be an SME, SMEs, in our view, according to the European Commission regulation, are all companies with fewer than 250 employees, a turnover of less than 50 million, or a balance sheet total of 43 million. What you might want to consider is that if companies are linked or partnered with other companies, like there's a shareholdership, those numbers will have to be added. So companies that you might consider to be an SME but who are owned by another company might actually not be. For those of you who haven't done so yet, to do business with ISA, it's necessary to register in ISA Star, ISA's procurement system, and this is also where you claim your SME status. So if there are any of you out there who haven't done so yet, I would suggest to click on this link. I believe the presentations will be shared later on, and to claim your status, because there are certain benefits associated with it. Just to give you a quick overview of the SME landscape within ISA, so in the period 13 to 17, we had about 940 companies, SMEs, with contracts. Some even had some more. Overall, we have 2,600 companies in our database which we consider to be SMEs, and as you see, they come from all walks of life, upstream, downstream, companies dedicated to space, but also from the non-space area nowadays who want to enter the space market. That's the complete picture. This is the SME policy I was referring to earlier, which we're implementing at the moment. And what I would just like to highlight here is that there are basically 4 areas. So there's general support, procurement, industrial policy, and finance. What might be important to know is that the first quadrant, general support, is more of an outreach area where there's direct interaction with industry. So it concerns training programs, networking, a newsletter we send out. The other areas are more agency internal. They concern improving the procurement processes and giving SMEs a place within the activities of the agency in that sense. Let me go to the general support measures, which might be of interest to you. We do have a training program which we established in 2016. Taking part is free of charge for SMEs. It's sufficient to just sign up to the program. There are a number of courses on offer. We have R&D proposal writing, product assurance, EEE procurement. If you click on the link here, you will get to our training calendar for 2019, and we recommend that all of you do this, because this is a good opportunity to get in touch with ISA experts, but also to find out and learn about the activities of the agency. Other things we are involved in is organizing events such as this, or supporting in various ISA member states. We've recently set up an SME point of contact network in various member states, which provides information to SMEs on a local basis. And an event I would really like to highlight are the Industry Space Days, which are organized by us at ESTEC every 2 years. As you see, it's like this event on a regional basis, a B2B networking event, which was attended in 2018 by about 1,500 companies, 1,500 participants from 900 companies in 39 states. The next Industry Space Days will take place on the 16th and 17th of September 2020, and we would really like to invite you to take part, have an exhibition stand, possibly attend B2B meetings, and meet all of European space industry, including our partners from the LSIs, but also ESA experts, and generally find out about how to do business with ESA, but also in the space sector in general. Information provision is also one of our key tasks, and here you see a list of all the different communication channels we have on offer at the moment. We have a website where you find all information that is of importance to SMEs who would like to engage with business with the agency. A Twitter channel, we have a help desk, so should any of you have any questions related to trainings, procurements, registrations, we're always available to help and can be contacted on this address. There's an SME database where you can showcase your capabilities online in a way that LSIs, ESA, and the rest of the space industry can see them. This is a bit outdated at the moment, but we are currently working on a successor of the system, which will allow you to do even more than what's currently on offer. I would like to invite you to sign up to our SME newsletter. It's a mail shot that we send out every month with all important information for SMEs and everything else you need to know. Regarding the other procurement measures, or the other measures of the SME policy I mentioned earlier, they're in the areas of procurement, finance, and industrial policy. I won't take too much of your time. What might be important to highlight is, for example, the new 35% advance payment measure. So when you have a contract with the agency or in one of the programs of the agency as an SME, you have the right to get a 35% advance payment from the very beginning. We have also implemented the PATP, so the preliminary order to proceed, which can also now be invoiceable at this stage. For the rest, they're the C1 to C4 procurement measures. So those measures are specifically targeted at small to medium-sized enterprises, especially the C3. So if you see a procurement in our system emails that's labeled as such, it's of particular interest to you, and I would like to highlight this possibility to you. If you would like to get in touch, as mentioned before, there are the various communication channels available, and we'll also be here in the afternoon for B2B meetings and any other questions you might have or discussions. Please feel free to get in touch, and I'm happy to engage in conversation. Thank you very much.
Wonderful, thank you, thank you. All right, that's it for the opening part. Now, the part that we all expect very much, of course, is the presentations by the large system integrators. And the first one would be Thales, Alenia Space, Miss Christelle Bogaarts. So the floor is yours. Remember the timing. It also, you know, being large is not always, you know, having more time. Anyway, so okay. Just be aware.
Oh, will it work? Okay, just to see. Okay, perfect. First, thank you for inviting us to this nice place and give the opportunity to meet newcomers and maybe comers already existing in space activity we don't know. So thank you very much. I'm Christelle Bogaarts. I'm in charge of developing business with Nordic and Baltic countries. So, and I'm here to present an overview of our activities. Clearly, in 5 minutes, this will be very short. But if you want to have more details, we have a break and B2B meeting. So this is just a short presentation of our activities. So Thales Alenia Space, it's a joint venture between two leaders, Thales Alenia Space and Telespazio. And this is just a picture of the sharing. So 67% Thales and 33% detained by Leonardo. And we have the opposite for Telespazio. So these two big companies represent what we call the Space Alliance, as just to give the opportunity to have a view of our sharing. Alors, key figures. So we are 8,000 employees, and there is 14 locations in Europe. And in terms of sales, it's 2.6 million euros of sales. Our locations, so this is our footprint. So we have companies, location in Toulouse, Cannes, in France. We are coming Madrid, Rome, Torino, L'Aquila, Gorgonzola in Italy, and also in Switzerland, in Belgium, in office in Germany, in office in Poland, and also different office in UK. In terms of business, so the breakdown per product, so we have 45% for institutional activities and with ESA, 35% for commercial activities and 20% for defense. And in terms of telecommunication and observation, because we could have business in telecommunication in also institutional program, the sharing is 57% for observation and exploration and so on, and 43% for telecommunication. So this is our activities. Our main customers, so we have in different, you can see different customers in different areas. So in science and exploration, in observation, in telecommunication, in military application. So you have the main operator for telecommunication. Our credo is space for life. This is what we want to promote in our activities, and we have 5 domains of activity: space to connect, space to secure and defense, space to observe, space to explore, and space to travel and navigate. So in terms of telecommunication, we made flexible satellites, and we have a product line called Spacebus Neo with electrical version, and so we also made a constellation, and for that we are the leader for constellation. Probably you heard about Global Star, O3b, and the next launch of the last 4 satellites for O3b will be end of this month, and also Iridium, 81 satellite order and now in orbit. So we are the worldwide leader for this. In terms of security, we have also different satellites in flight or which fly. Syracuse, Cosmos Skymed, Helios, Pleiad, and now the new generation of optical satellite for export, Falcon Eye, and what we call Mohammed 6A and 6B, the satellite for Morocco. We have also Ceres, which are currently be built in our facilities for electromagnetic intelligence, and different others. I'm sorry, 35 seconds. In terms of navigation, we have all of this. We are part of Galileo. We are part also on EGNOS. And now we recently we will build a constellation with CLS for million of connected objects. So it's called Kineis. In terms of climate, we are the prime contractor since now a long time for all European meteorological satellites. So now it's meteorological 3rd generation, MTG. So we are world leadership in operational oceanography with the help of Sentinel. And in terms of universe, we also be part of the exploring the universe. So, for example, ExoMars, for example, Baby Colombo, Euclid, and the new ESA missions, for example, the lunar module, Esprit, and all the future ESA missions. Done.
Wow. It is actually possible. Right. Can you hear me? I have a loud voice anyway. So, good, thank you. Yeah, that's it. Run. Right, so we have a next company, and it's a well-known company, Airbus. And Thierry Gardet is here to give a short presentation, say 4.5 minutes. All right?
Okay, good morning, everyone. First, I would like to thank ESA and national organization for inviting us for this day. I am not alone. I came with my friend Andreas, who is R&D responsible, and for me, I represent the procurement organization. Okay, I think you know Airbus, because you have the three divisions: aircraft, Airbus helicopters, and also defense and space. I think I will pass very rapidly, but in Airbus Defense and Space, we have three divisions. One is military aircraft. The second one is communication, intelligence, and service, which is using the information coming from satellite, mainly, but also for border security activities, for cyber security. And the last, but the best one is the space system divisions, where we have different activities as telecom satellite, Earth observation, navigation, scientific, UAV, and space exploration, for example. Okay? You see the different main activities, and Galileo, and there are launcher and defense. The launcher is mainly Ariane Group is a joint venture between Airbus Defense and Space and Safran, and is in the joint venture. Okay, and we are working with us, and I am supporting them for different sourcing activities. Okay, I think I will pass rapidly on this. This is only to say that sorry, I think it will be better like this. Okay. Yes, we are still the first. Okay. You are on? Yes, it's okay. Okay. Yes, we are the number one in the supplier for Earth observation satellite, and we work also with NASA for different applications. We delivered last week or 2 weeks ago Orion, the vessel for NASA. We are also 9,500 people, and probably this number is obsolete because we have a lot of new employees in Airbus Toulouse. And you see the different seats. I will not go in detail on this. Airbus policy. First, we are well supporting ESA policy for SME and also for industrial policy. First, for ESA programs, we are doing some preference to SME and to European companies for having cost effectiveness. Also supporting the technology development, and we have a lot of partnership with different companies and also with universities or institutes. And we are developing this technology, the TRL level, and after we are embarking some SME, some new technology for increasing our competitiveness. Develop a solid and competitive industrial basis, yes, and it is why we are systematically present in this type of event in ESD, and we take the opportunity to meet a lot of companies and also universities for developing both sides and to well analyze the different opportunities. And after this is completely discussed internally for knowing if we can work with you on the specific technology. Okay, it's only 50 minutes, sorry. Our objective is anticipate with new member states, favor the open R&D, prepare future programs, and reinforce Airbus industrial knowledge. All information you will give us today, I will ask you to send me by email your company presentation or your university institute presentation. This is capitalized in the big database, and after it is useful for everything, not only ESA, but also for other industrial activities. Yes, just for saying that our policy in terms of procurement, we are developing first a partnership, but also we need on-time delivery, quality, and competitive cost. I have finished. But in fact, just read, if you need, I will ask to write this email address, and don't hesitate to send me a mail to ask me some question. I will support you, and I will clarify any question. I will answer to this. Okay? And this afternoon we have a lot of B2B on both sides with Andreas and me for procurement and Andreas for R&D. Okay. Have a nice day.
Thank you. Thank you. Yeah. So be prepared to have some, I don't know, 50 more emails today. Something about that. Good. Good. And last of the three large system integrators, the company named OHB. Can you please introduce yourself? Because I'm really scared to mispronounce your name.
Yeah.
All right. Thanks.
So I'm Séverine Jacquet. Sorry, it's a French name. From OHB in the business development. And good morning, and thank you for having me presenting OHB. So OHB is Germany's first listed technology company and employs around 3,000 people around Europe. The company is divided into two branches: the space systems for the design, development, and implementation of space projects, and aerospace and industrial products that cover the products and manufacturing for aerospace and telematics. OHB's value chain includes the satellite design, manufacturing and operation, the data transmission and processing, the design, development and manufacturing of scientific payloads and structures for aerospace applications. And on the right-hand side, you can see OHB and its sister companies, and we should also include the newest OHB company, the OHB Hellas and Czech, in the space system parts, and also a third block as we are starting digging into the application sector. Taking a look at the OHB facilities, OHB has two sites in Germany. The first one is in Bremen. It's the headquarters where there are 3 ISO 8 rooms. In the Galileo Hall, there are these ExoMars and MTG missions, and a new hall is currently under building, and that will host an additional ISO 8 clean room, integration hall, and offices. And the second site is in Oberpfaffenhofen in Munich, where I'm working. And it focuses on science instruments and optical payloads. And there is also one ISO 8 and one ISO 5 clean room. So OHB is covering the whole space domain, and it manages projects from small-scale payloads and missions to large-scale satellites and space infrastructures. For example, in the Earth observation, we have the MTG mission to have meteorological space data and having improved weather forecasting. Also the EnMAP project, it's an optical Earth remote sensing mission to acquire high-quality spectral image data. And OHB is responsible for the development, production, and launch of the EnMAP satellites. In navigation, OHB is the prime contractor for the design and realization of the Galileo satellites, and OHB recently acquired the contract for the Batch 4, the next generation of Galileo satellites. In exploration and science, we are doing missions like ExoMars. It's a mission to know whether life ever existed on Mars. OHB provides the carrier, the sample distribution system, the high-resolution camera, and a spectrometer. And also the Plato mission, it's a mission to detect Earth-sized exoplanets. In the security, we developed the German satellite-based reconnaissance system Saarlupe, and we are currently in charge of the next generation, Sarah. We also do some technology and telecommunications, and human spaceflight. OHB contributed to the ISS infrastructure development, such as the Columbus module, but also to internal facilities like the European Physiology module to conduct physiological experiments in space. And we are also involved in the Dream Chaser study. It's a study to investigate how this cargo module could carry on research under wireless conditions. So that was it. If you have questions, don't hesitate to use the break to come to me, and also during the B2B, also send an email to my email address. Thank you.
All right, thank you. 3.5 minutes, and it's done. Well, guys, I feel like in speed dating or some kind of beauty contest, I don't know. Well, good news, almost done, just 35 presentations more. Well, why not? So, the schedule is quite tough, as I mentioned before, 21 presentations in the first block, which is more or less related to upstream, and then coffee break, just 20 minutes. And then 14 more presentations related to downstream. I believe you know these keywords by heart. And so the first block is related to structures, materials, and processes. The first presentation is going to be done by Latvian State Institute of Wood Chemistry. And the next one is Fact Industries from Estonia, so be well prepared. In my other part of my life, I train public speaking and pitching, actually. So whenever you have 5 minute limitation, just be prepared to speak like for 4 minutes. So that's a good formula for today, I guess. All right?
Good morning. It's my pleasure to be the first presenter from Baltic states. I represent Latvian State Institute of Wood Chemistry. Maybe it looks like very strange, wood chemistry, but in this meeting I represent Laboratory of Polymers, and our experience and our knowledge is about developing of thermal insulation materials and cryogenic insulation materials. And we are cooperating with space industry since Soviet times, but approximately in 2004 or 2006 we start cooperation with European Space Agency, especially with company in Bremen, and a lot of names changed for this company for this time. Start with Astrium, after that Airbus Defense and Space, Airbus Safran Launcher, but now we have received money from Ariane Group. Yes, we are developing cryogenic materials for insulation of fuel tanks. As you know, fuel for space launcher is liquefied hydrogen and liquefied oxygen. It is very low temperatures, and we have experience and knowledge in this. And in the last two calls, we were partners in PEX activities. We finished one project, and one project is already ongoing. And yes, we are open for cooperation, but especially in material science, in development and test of cryogenic materials. Thank you. Maybe I have prepared some slides, but I did it. I did it some two months ago. I don't remember what I've written in my slides, but okay, we are experienced in development of cryogenics, a lot of equipment, classical chemical and physical mechanical test laboratory. What else? Yes. Thank you.
Nice, nice. Good opening in just 2 minutes. Wonderful. Good. So, Fact Industries, are you here? Yeah. Yeah.
2 minutes or not?
Yeah, well.
No, it's fine.
Anyway. And after Fact Industries from Latvia Institute of Materials and Structures of Riga Technical University. All right?
Yeah. Oops, yeah, okay. Hello, I'm Marina from Fact Industries. I'm happy to present this company. We are a team of scientists, material scientists, additive manufacturer, engineers, which are motivated to solve big problems. Our company is divided in 3 big departments. One is this technology providing. Here we are solving the problems of companies, starting from printing of ceramic materials, also preparing powders or adapting powders to additive manufacturing, like making feedstock. Another department is devoted to 3D printing services. So we are printing metal-based or plastic-based components, which can be your prototype or which can be also implants, starting from implants to different prototypes. Another department is devoted to thermal management systems. Here we have developed new kind of powders, which is which is light and has high thermal conductivity. Also, it's possible to manage with thermal expansion coefficient, so it is adaptable. We have specialists, quite multidisciplinary specialists in additive manufacturing, and we cover all these technologies. If we don't have the facility, there are some couple, for example, if we don't have cold spare AM, in this case we have the specialists and we have contract with different universities and institutions all over the world. that if needed, we send our specialist, and based on our contract, this university or institution will provide their infrastructure to use. But in-house, we have selective laser melting, fit deposition modeling, and binder jet, which we use in order to prepare ceramic components. But when we start the work to solve the problem, at first we start from the feedstock production exactly for that AM technology. For example, for selective laser melting, it's for metal-based device, to print metals. In order to use it for ceramics, we prepare a unique feedstock, which makes it possible to print the component by that SLM method. And for this, we use different synthesis or production technologies. This can be combustion synthesis, freeze granulation, molten salt, etc. We have also a contract, again, with universities to use like spray dryer or atomizer, small lab scale atomizer. We have big portfolio because all our scientists and all our team member has huge experience in additive manufacturing, over 15 years, and in material science over 30 years experience. And here are the some systems, like small part of this big portfolio, where we can say that we could successfully print pure silicon. Actually, we have better result than here. This presentation was prepared before. Now we can get up to 98% silicon, pure silicon printed by SLM in one stage without post-treatment. We have aluminum nitride silicon carbide aluminum, again full density. This is here. What is the uniqueness of this is has high thermal conductivity, higher than AlSiC, and we can also manage here the thermal expansion coefficient. We have already succeeded in printing silicon carbide silicon system, full density, and now we are trying to have only silicon carbide, pure silicon carbide without additives, full density. Also, one of our unique, nice work was molybdenum disilicide silicon, full density by 3D printing by SLM without post-treatment. We have also molybdenum disilicide silicon nitride, but well, it's not presented here. We have like long list of such kind of reference product, but so we can't present all of them here. All these are gained due to the great team. Here is the core team, decision makers, let's say, but the team is bigger, and if necessary, based on the project, we invite or accept some other colleagues, scientists, in order to carry on technology developing process. Thank you.
Thank you. Thank you. All right. As relating to the next speaker from RTU, he's already here, but then be ready, cryogenic and vacuum systems after Kaspars. All right?
Thank you. Here goes my slides. Yes. Hi, I'm Kaspars Kalniņš from Materials and Structures. So basically, we are an institute working on composites. So composites is about advanced things which cost a lot. So you need to save on material to invest in research. So R&D part is something what we are aiming for. So what we're doing in our daily basis is about numerical simulations, testing, prototyping, developing, and making a scaling up of different technologies. So it includes thermosets, thermoplastics, which is typically used as structures, hardware of any item in space and ground and everywhere. So I thought there was 2 slides before it. Anyhow, there should be like 1 slide about PEX project, which is my next topic. Oh, okay. Sorry, I'm not as advanced. Anyhow, within the PEX program, or within the space agency's current state of art, we've been involved in 2 different projects. So technically, it's about honeycomb structures, making a satellites. If you can imagine, if something drops on the satellite during the assembly, it could cause a lot of consequences. And it's not a consequence that if you're going to hit the butterfly, you know, something, weather going to change in USA. But this is quite a similar one. So we're trying to investigate what's going to happen and how to handle mishaps and how to include in certification procedures. So technically what we've been working during the last years is about cooperation with us and with German Aerospace about certification and approval methodologies for launchers and satellite structures. So with this one, we have plenty of different fancy equipment which costs a lot and has a particular purpose for applications, so from laser scanners to the mechanical testing ones. So everybody who's looking for advanced testing facilities and advanced testing capabilities, that's where to go for. And next slide, so what we are looking for. Technically, there's many fields where we are active in, so I think there's a competence, what we can share for for hardware and for structural developments. It's not only satellites, launchers, it could be a lot of different things, including the electronics in it. So if you want to do the shaking tests, self-frequency tests, etc., that's one part which could be cross border between the mechanical part, what we are experts in, and those we are, let's say, going more to the physics, etc. So yes, it would be nice to find the primes. I wasn't sure 2 months before when I prepared the slide, I wasn't sure that we are talking these primes here, but I'm very, very happy to have them, and I'm looking forward for nice discussions. I said my time?
Nice, thank you. We are all very thankful if somebody saves time. It's interesting that almost all of the speakers mentioned that slides were prepared like 2 months ago. I don't really remember what was on the slides. Yeah, it's fine. You don't have to mention that one, but probably you could review your slides a bit, I would say. So cryogenic and vacuum systems now. The next would be Workshop of Photonics from Lithuania.
So, hello everybody, we are cryogenic and vacuum system. Where are we now? Yeah. Thank you very much. So we are just 5 years old, but within these 5 years we have a little experience in space simulators, producing vacuum equipment, producing cryogenic equipment, producing some testing equipment production, and also applied research instruments production. So we have small laboratory. We are located in Ventspils. It's a small city in Latvia, but we have small laboratories, also small production facility, and have some experience in space simulators, as I've told you before. They including sun simulators, cryogenic system, high vacuum system, system of measurement of residual gases, system of measurement of vacuum, system of temperature measurement, and so on. Also, we have experience in production of small and high vacuum station, vacuum measurement systems, cryogenic pipelines, cryogenic pump stations. 2 years before, we have European Commission award for our idea of mobile space simulator, which are moving through the Europe and have space testing at all companies who have desire to test something, because it's quite difficult to arrange testing in existing stationary facility. And we have also this certificate of excellence for development of this idea. We have a lot of partners here and abroad. Most of the main of them are here. It's Baltic Scientific Instruments and also Riga Technical University, Institute of Aeronautic, Ventspils, our scholar, Ventspils University. And for what we will be suitable for our potential partners? For vacuum systems, space simulators, cryogenic system, cryogenic testing equipment. Also, if you need to test something in liquid helium, it's okay, it's for us. So that's all. Thank you very much.
All right, this goes way better than expected. Would you agree with that? It's bearable. Oh, nice, nice. FEMTIKA, are you here? Good, you're next. All right.
Okay, hello everybody. And Workshop of Photonics is a small enterprise in Lithuania, which is not yet in space industry, but we like to be there. And why? So if Marina and Kaspars produce some crazy material, you have to fabricate it. And then you come to us, and we do it. How we do this? So we develop and manufacture femtosecond laser micromachining systems, which means that no material can withstand these machines when you put femtosecond pulse to material. We can provide you with technology unique for special materials, and we also manufacture some special optics elements, which are also crazy elements. So, what we can do? We work on extremely precise and specific materials. You can see that the fiber is a big piece for us. So we are extremely proud of this example. It is a probe for sample from cell. It is made from glass, 20 microns thick, and we have to drill 5 microns hole in one wall without damaging opposite hole. And we do this if you need. We work on very precise things, and we are especially strong with transparent materials like glass, sapphire, and so on. Here you can see some examples of what we do with glass. What we do with other materials. It is ceramics, it is metal, as I mentioned, fiber. We cut any material, of course, with limited thickness, in any shape. And what could be also interesting for space industry, we work in welding dissimilar materials, meaning if you need to weld your lens or mirror to the metal holder, we can help it. And as I mentioned, we can produce very specific optical elements, which are based on modification of retardants and birefringence in the transparent materials, which make very interesting things with your laser beam. So that's it. Thank you.
Yeah, it's amazing, you know. You tell the scientist you have only 5 minutes. I just need 3. And I've never seen something like that in scientific events, but that's really nice. Okay, FEMTIKA now, and the next company would be from Lithuania, Standa. Yes, good.
I did something wrong. Okay, my name is Valdas Monkus. I'm Business Development Manager of company FEMTIKA. FEMTIKA is a spin-off from Vilnius University. We are very much scientific company. We have 23 people. Out of these, we have 2 PhDs. Oops. 2 PhDs. We have 2 PhDs and 5 pre-PhDs, and this is why we are very much oriented towards research and development. We already very active participant in Horizon 2020. We are priming one very big contract in Europe. We also have 2 Eurostars projects right now ongoing, and if you are looking to the current our market areas where we are very interested in to be, so in space technology we can help you with the precise ceramic fabrication and also nanomarking, which is coming more and more popular, to know what parts and where and who produced and where you are placing them, and if they are breaking, so what was the reason, just for tracking. We are also supporting some medical activities with microscaffolds and sensors. Bio-based sensors is one of our project sponsored by EU funding in Lithuania called Intellect Plus. And like our colleagues from Workshop of Photonics, we are also working in micro-optics, like 3D microstructures on fiber tip and so on. But the most important thing is what our main mission is, again, main mission is to have this kind of our baby. This is laser nanofactory. This laser nanofactory is a machine with a femtosecond laser inside, and we can use this machine at once for additive and subtractive manufacturing. So that means that no changes required. This machine is supported also by our proprietary software, which is with which software you can import any drawings of elements, and then after that you also run the software during the manufacturing. These are the samples we can produce. So key technologies is multi-photon polymerization, laser ablation, selective laser etching, welding. Current and plans developments we have also, you can see, we would like to be in micro and nano parts producing for satellite industry. And our desired contacts would be partners or clients in satellite and manufacturing industry. So that's it. Thank you.
Well, just a few technical remarks here. So the room needs microphones, and also the live stream needs microphones. So if you do not stand at the podium, please use the handheld mic, okay? And it's not something for just looks. It's actually meant to be here, near your mouth.
Okay, I think my voice...
No, we have a live stream, so we need you to use mics.
Sorry.
So, could you... Or this...
Hello.
All right.
Hi there.
I can be very convincing, you know, it's... all right. Okay, Standa now, and the next one will be Vilnius Gediminas Technical University.
Okay, hello. How are you here? Nice to see such a huge audience of people. I'm Artur Pishalov from company Standa. I'm presenting the manufacturing and research and producing company from Lithuania. So our company started like 32 years ago. So at the moment we have like 200 people in production. So we're starting from the raw material, developing the products, and preparing it for the commercialization and offer it to the market. So our activity is mechanical structures or vibration isolation systems, robotics and adjustment equipment for normal environment and for vacuum or for harsh environment, and also laser systems. So what about the company? So as I told before, we are 32 years in the market. So Standa is world famous manufacturer of scientific and industrial equipment, instrumentation for a normal and harsh environment. We are comfortable to work in a vacuum like 10-8. I mean robotics for the vacuum up to 10-8, and low temperatures as -40, -60 to +60, and dusty environments. So company offers wide range of high quality from shelf and customized products for cutting edge research and industrial applications such as vibration isolation systems, adjusting equipments, and lasers and robotics. Using Standa motion control solutions, we can simplify and solve wide range of problems from small research lab to big synchrotrons. Our customers are CERN, NASA, Soleil, DESI, XFEL. And so we're also offering very compact SLM lasers in nanosecond and picosecond range for diagnostics, LIPS, LIDARs, material processing, and spectroscopy. Our current market areas is like lasers, photonics, metrology, and robotics. For the harsh environments, our current market areas are more or less space simulation systems and vacuum systems. industrial robotic systems for the micro and nano fabrication and machining, and compact laser systems for a very efficient diagnostic spectroscopy or medicine, let's say. So our main production facility is located in Lithuania, in Vilnius, near the city center. We have more than 200 people inside, like 60 machines, 2 shifts, very wide range of the mechanical technologies, from very small parts and polishing processes to very big parts and big structures. Our last project is a mirror holder for 1 meter 200 millimeter mirrors for the optical interferometry, for the optical production. So the weight of the mirror is 500 kilos, and the lambda, the flatness of the mirror is lambda by 20. So this is some of the examples of our facility. So yeah. So our K technology profile and what we do. So we are making low frequency vibration isolation system and honeycomb structures, micro nano positioning systems and robotics, precise and clean mechanical systems, SLM lasers, and we can also clean and prepare everything for the clean or the harsh environment. And what we are planning for the space, so we are planning to produce and develop open loop linear micro positioning devices, or we are planning to research, develop, and produce like open loop rotary micro positioning devices. So, and desired contacts are micro nano space system integrator, supplier of micro switches, material services for the testing of the robotic systems, and the customers preferably should be like macro space system integrator. Thank you.
Thank you. I need to ask the large system integrators, is it going well? Is the format okay? You know, well, not that I could change it currently, but anyway, you know, maybe too what? Too long? Ah, okay. Well, okay. Another team from Vilnius, Vilnius Gediminas Technical University, and the next one will be Fiber Optical Solutions from Latvia.
Yeah, good morning everybody. It's a pleasure for me to represent my university. My name is Laurynas, and our university is a leading technical university in Lithuania on focus on the technology and engineering. We are already more than 50 years old, and we have about 10,000 students and 1,000 members in academic staff. Our key research areas as pertaining to space applications is mechatronics and ICT sector, fundamental research on materials and processes. Historically, our university was strong in civil engineering, but now we are ambitious and want to also work in a space sector. We started about 5 years ago with the first Lithuanian satellite project. So this is just a picture. We have equipment to do vibration testing of small satellites, not large, but let's say CubeSat type, up to 4 kilos. So like a 3-unit CubeSat, if you are familiar with the standard. And this is the expertise of Laboratory of Experimental Mechanics. And they also specializing in vibroacoustic measurements, so like measurement of noise produced by reaction wheels in the satellite and such kind of things. Also, as I said, our university is historically strong in materials research, so more for like building infrastructure, but also could be the expertise in modeling of particles and small materials could be also used for space. And in my institute where I'm working, in Institute of Aviation, we are also looking into the emerging field of high altitude pseudo-satellites, which ESA is also currently interested, and we think that could be a very interesting application, like an intermediary between space and aviation, where we could be strong. So we have a lab and where we produce solar-powered UAVs for achieving a long time of flight. So we are looking beyond the horizon. What is the purpose of university is to look beyond the horizon and see what new technologies are needed. So one of the areas we are interested is the precision piezo actuators, especially for smaller satellites, because that's something we think will be needed in the near future, as the capabilities and needs for small satellites are increasing. Also, this is the mechanical and thermal modeling of spacecraft structures is the field which I'm interested in, and I'm doing a PhD in this field. So this is also one of the areas we're interested in working. And of course, the unmanned aerial vehicles, as I said previously. What are the current and planned activities? We think that a very new and prospective technology is the quantum communications, and we are working in the fine-pointing systems for small satellites that could be used potentially for providing quantum keys from space. If you are familiar with this technology, I would be happy to discuss that during meetings. We're also developing a shock test bench for small satellites for the company Nanoavionics, which is based in Vilnius, Lithuania. They are the CubeSat systems integrator. And we're also thinking that thermal control louvers, micro louvers for small satellites are currently in need because the capabilities and power consumption is growing for small satellites. And high altitude pseudo satellites. Yeah, and we would be happy to discuss any collaboration with you. So thank you for listening.
Thank you. So we shall continue with Optomechanics block with a company named Fiber Optical Solutions, and the next one will be Kaunas University of Technology. Are you here? Good.
Hello, good morning. I represent a company named Fiber Optical Solution. I'm CEO of this company. We are 7 years old, but our history is much more longer. We founded on the base of international company Optolink, based in Russia. What happened?
Wrong button.
Oh, maybe. Huh?
Never do this in space. It's okay. It's just. Yeah.
Next it's this one, yeah?
No, just.
Our activity based. We produce mainly fiber optical products, mainly fiber optical gyroscopes, inertial measurement units, and step-down navigation systems based on fiber optical gyroscopes. We are vertically integrated company, so it means that we have in our hands all technology, all key technologies necessary for making fiber optical gyros. It's a special fiber, polarization maintaining fiber. It's integrated optical elements based on lithium niobate. Only 2 companies in the world, in Europe, have such technology, and we have full technological steps for making fiber optical gyros, including space grade fiber optical gyro. We have 2 factories here in Riga. One is for integrated optics, based on lithium niobate, and second for making fiber, special fiber, and fiber optical gyros. We have all facilities for testing, calibration of such products. As for our history, starting from 2005, all Russian spacecraft Soyuz equipped with our gyros. So it was about 80 successful launches of this spacecraft, no accident during this time, during these 14 years. Some satellites now working on orbit. It's Singaporean Teleos 1, Dubai Khalifa Sat 1, Dubai Sat 2. It's now in space. Not about 4 geostationary Russian satellites equipped with our gyros now. Its oldest is in 5 years, launched in 2040. So we have quite big experience in supplying fiber optical gyros and inertial measurement units for space application. Also, fiber optical solution is an official supply of NASA. We supplied them high precision fiber optical gyroscopes for balloon telescope, but the telescope placed in balloon, and it's for stabilization of telescope at the altitude about 40 kilometers. So, briefly, it's all. Thank you.
Thank you. All right, before we start the block of optoelectronics with the company Lidaris, Kaunas University of Technology is presenting now. All right.
Hello. So I'm representing Kaunas University of Technology, particularly Institute of Mechatronics, but we are several institutes here today. So Mechatronic Institute working in various field of activities, which requires control, mechanics knowledge, electronics, and sensorics. So basically those industries working with metals, machinery, electronics, defense and space, and human health and sports technology. We have some equipment for nanosatellites testing, as well as Gediminas Technical University, as mentioned, which can basically conduct experiments on gravity, shocks, and vibrations, many modes. Other knowledge and know-how is vibrometry, laser vibrometry, which we use for big systems, and PSV 500 3D measurement system, and Politics MSA for MEMS testing. We also have equipment for micro indentation and micro scratch, which can be used for coatings and ceramics, metals, and polymers testing. Mechanical properties, some equipment which are used for composites and metal structures testing, so liner torsional fatigue testing, machine speed, high-speed impact machines, ultra-high-speed cameras. Some equipment for electronics pre-compilance testing also is at our university. Which I want to emphasize what we are. If technical guys would press on this green screen, it will move. Okay, so we're strong in vibromotors and piezo actuators. If someone interested in that, could you please? No. Okay. No. So basically, I wanted to say that this piezo motor is basically attached to at those points, and it moves without bearings, basically by piezo actuators. So we are strong in vibromotors and piezo actuators. Also, we're working quite a lot with energy harvesting devices. So this is one of example. So our planned development would be high resolution attitude control for coupling of piezo reaction wheels with reaction wheels, antenna deployment systems, and solar panel deployment. Partners we are looking is institutes and companies which are working in Earth observation, attitude control, and satellite hardware developers. We are particularly interested in friction and wear resistant coatings, precise mechanical manufacturings. So that's it. Thank you for attention.
Thank you. All right, we're now entering into a subsection related to optics and optoelectronics, and the first company from this section is Lidaris from Lithuania, and then we'll hear from Baltic Scientific Instruments.
So, hello everyone, my name is Gintarė. I represent company Lidaris from Lithuania, and we provide professional laser damage testing. As everyone here knows, in order to go to space, you have to do a lot of work on Earth. And in our field of view, a nice example of that is Aeolus satellite, which was launched last summer. So in order to carry out this mission, the satellite carries 2 powerful lasers inside. And inside each of these lasers, there are tens of optical elements. And if any of these optical elements get damaged during the space mission, this basically means trouble. Most likely very expensive trouble, and even potentially mission-ending problems, right? So in order to launch powerful lasers in space, we have to characterize each optical element on Earth. And that's what Lidaris do. We take optical elements, we apply smart irradiation algorithm on the surface of the samples. We collect data of damage and non-damage points, and we use this statistic to extract efficient but safe limits to work for your optical element, the so-called threshold. Unfortunately, for Earth application, we only characterize this optics up to 1,000 laser pulses. So no one actually knows what happens with optical element after billions of laser pulses or a few years of work, which is the key interest for the space application. In Lidaris, our core competencies are advancement in laser damage metrology. We have 5 PhD employees on our team, so we decided that this question is for us to answer. So 3 years ago, we joined forces with European Space Agency for the project ESPRESSO, which stands for Essential Preparation Steps for Qualification Longevity of Space Optics. Fittingly, we also drink a lot of espresso, especially next to the deadlines of this project, but it was all worth it because we find out that there is two key physical mechanisms which causes optics to break. This is really not very good visualization. Okay. Oh, do you have this? Yeah. So what we found is that there is 2 key mechanisms. One which is easily to track and what we normally do, and the other one is way harder to see, they harder to define and way harder to track. But after this revelation, we were able to tune our systems of measuring and our statistical methods, and now we can claim that it's possible to predict what happens with optical element after years of exposure. And that's what we present here, the possibility to characterize your optics for longevity, meaning billions of laser pulses. And believe it or not, that's also interesting for people on Earth. So if you are interested to characterize your optics, you can do that at Lidaris at various regimes, going from nano, pico to femto, from UV to infrared, and also in extreme conditions like cryogenic temperatures or vacuum. Also to apply a lot of testing algorithms there. So what we are looking here, so we are looking for partners, everyone who sell, manufacture or use laser optics for powerful laser optics applications. Thank you.
Thank you. You've been sitting quite long. I've been standing all the time and just sat down and I thought, whoa, this is harsh sitting that long, so I have an exercise for you. There's this word, savubona. In African Zulu it means hello, but in their language it also means I see you. And I see your personality. So it has a deeper meaning than just hi. So I want you guys to stand up now. Turn to your right, say hello and I see you. Turn to your left, hello, I see you. Nice to be here. Nice. All right. Some freshness in your faces. That's nice. Well, some people even saw people from other rows. That's nice. Wonderful. All right. I've prepared the audience for you. So now we're going to hear from Baltic Scientific Instruments. The next one is Exma Optics from Lithuania.
Well, good morning, everybody. My name is Vladimir Gastila, and I represent Baltic Scientific Instruments company from Riga. So, company is specialized in development and fabrication of semiconductors, installation detectors for registration of X-ray, gamma rays in different applications, and also we design and fabricate different types of equipment based on fabricated by us detectors, also for different application. Main our market, that is nuclear industry, environment monitoring, but also we deliver our devices for mining industry, medicine, healthcare, and for space applications. We also fabricated many type of detectors and devices. So mainly, if to speak concerning space applications, we are in X and gamma ray detectors technologies, both in single detectors for precise X and gamma ray registration, and also in pixel strip detectors for imaging applications. And as I said, based on these devices, detectors, we fabricate different devices. So, in our facility, we have full technological cycle for development and fabrication of different type of semiconductor detectors based on different materials, and also for design and fabrication of equipment. Technological operations, different technologies which we have, you can see here. So it provides for us possibility to be flexible, to design and manufacture everything ourselves. So all technologies are in our hands in our facility. For realization of our project, we have different departments. Department of Semiconductor Detectors, Designer Bureau, which provide drawings for all our products. Spectrometric Department, Vacuum and Cryogenic, Nuclear Electronics. Analytical Department, mainly working in XRF analysis. And Mechanical Workshop, where we fabricate all our devices. Different, you see here, different our technological departments, technological equipment, mainly for processing of semiconductor crystals, semiconductor materials. Some more pictures for that. Oh. Sorry, I did something. So, concerning special devices for space applications, which we fabricated for different organizations, we have experience to work with European Space Agency, with NASA, Italian Space Research Institute, Russian Space Research Institute, China, different countries. So that is pixelated detectors for imaging system in space applications, in medical applications. That is precise gamma spectrometer for orbiter to register content of minerals on the surface of different planets without atmosphere. That is what we're working with at present. That is high purity germanium pixelated detector, which are the most precise for imaging applications. That is such industrial prototype of device which can be used on the landers for register of contents of elements on the planet with atmosphere, like for example Mars. So here you see conveyor belt and our stationary XRF analyzer. So small version of such devices we can fabricate, for example, for register of minerals on the different planets. So that's all. Thank you very much.
Thank you. EXMA now, and then FTMC.
Hello. My name is Daugirdas Kuzma. I'm from EXMA company. I'm marketing and business development in the company.
Imagine being in a spaceship. There are more buttons there. There's just 4 here, right? So maybe not try all them all. Just this one, okay? Just wait a sec.
Okay, let's go. So EXMA Optics is a company manufacturer of laser components, optical, crystal, and electro-optical components. Actually, company was established in 2006, but we have roots coming to 1983 when the first laser company was established in Vilnius. Currently, we export about 75% of our optical components in sales and export worldwide to more than 60 countries. This year we forecast 12.5 million euros sales. We have 33 employees, 6 in R&D, quality control 5 people, and 29 manufacturing. Key products for laser OEM manufacturers in industrial, scientific, and medical fields. So our main products are laser optics for high power lasers operating from 193 nanometers up to 20 microns in wavelength range, nonlinear frequency conversion crystals, laser media crystals, passive Q switches, Raman wavelength shifters. Also we make Pocal cells with high voltage drivers and ultra fast laser pulse pickers based on our Pocal cells. We have several different facilities in the company. On the left picture you can see IBS, ion beam sputtering technology coating facility. Currently we have 3 machines for coatings in this facility. Also we have a CNC lens production facility where we produce spherical, aspherical, oxycon laser lenses. Also we have assembling in clean rooms, which corresponds to ISO class 5. Also we have nonlinear crystals polishing facilities, and here we can see our infrared crystals polishing facility. So key technologies and competences. So I mentioned already IBS coatings for the range from 300 up to 3000 nanometer for laser optics and crystals, ultra-fast Pockels cells and ultra-fast pulse pickers, infrared crystals. We do polishing and broadband coatings for infrared crystals, which operates from 1 to 16 micron range. We also have, we developed very high laser-induced damage threshold laser mirrors. Actually, we guarantee laser damage more than 50 joules per square centimeter for 1 micron laser, 10 nanosecond, 20 hertz, and this was measured under ISO procedures. We also produce low group dispersion delay laser mirrors for ultra-fast lasers and other optical components for high-power lasers like dichroic mirrors, harmonic separators, beam splitters, notch filters, thin film polarizers. Actually, we have experience to apply more than 100 coating layers for special filter components. Also, we produce, already mentioned, we produce spherical, aspherical, and oxycon lenses from 6 to 150 millimeter in diameter. And lenses can be made from fused silica, suprasil, infrasil, high refractive glasses, high refractive index glasses, and of course NBK7 as well. Also in the company we have optical system design, which we use ZMAX, SolidWorks. And what is potential use in space? The coatings for harmonic generation of frequency conversion crystals like LBO, BBO, KTP, or those crystals also can be as electro-optical crystals. And another thing, it's laser optics coated with non-porous, reliable, hard, long lifetime dielectric IBS coatings, which suits for applications, for high power applications in vacuum. That's all.
Thank you. I was listening to this presentation. It's sort of English, but then again, do you guys get this? I mean, good, I hope. Well, I'm not a specialist in these technologies, but sounds impressive anyhow. All right, we shall continue with the company named FTMC, and then we'll hear from HEE Photonic Labs.
Hello, I am Karolis Tashys, Innovation Manager for Center for Physical Sciences and Technology. So to begin with, we are the biggest research institution in the Baltic states, and we work in many fields such as chemistry, surface coatings, nanotechnology, optoelectronics, laser developments, aeronautics, and environmental monitoring. But today, I'm not representing all of those fields, but today we are semiconductor foundry and chemical coating developer. And what we can offer to you all. So first of all, we have a very strong experience in optoelectronics, especially in gallium arsenide systems, which can be used in analytical instruments. And as a key infrastructure, we have clean rooms up to ISO 5. And we have more than 20 high upkeep laboratories which are ready to develop new technologies. Our main competences are in molecular beam epitaxy. As I have mentioned, we are working in with gallium arsenide material system, and we have a very strong presence with bismuth technology. What we can do with this technology? Well, we can produce quantum cascade lasers, laser diodes, very small, very low power consumption, and very high energy output. And they are very small in size, very lightweight, which can be used in the space industry. Also, we can create light detectors, And our lasers and light detectors are working in the infrared range from 1 micron up to 20 microns. So this range can be used in gas sensing, material investigations, and telecommunications, which is very important because it can give very high speed. Especially we are now working on a project for inter-subband lasers, which can highly increase the communication rates. Also, as a semiconductor foundry, we can produce gallium arsenide tandem solar cells, which are the powerhouse for small satellites. And also we are working with bismuth technology to improve the solar cells efficiency. So anyone who is working in system integration and satellite creation, we can cooperate together to integrate our solar cells into your systems. And here we can see a sample of our laser diodes. They are very small. This is about 5 millimeters. And it can be integrated into very small analytical instruments. And they are very robust, and they has very high energy efficiency. So that will be very short. And we are looking for partnership. So I think we will talk more during the B2B meetings and during the coffee breaks. So I will give you a very short introduction of what we do, because I can talk for about 1 day about all our competences.
Well, then how many days do we need if everybody does that? Thank you for being on time, actually beyond that. All right, the last player in the optoelectronics field, HEE Photonics Lab, hopefully pronouncing this correctly. And then afterwards, Baltic Institute of Advanced Technology.
So we are a small company from Riga, and, but we have
but we have long-term experience in satellite laser ranging, and our experience is based on a team of researchers of University of Latvia who started with design of satellite laser rangings still in Soviet times, and designed a lot of satellite laser rangings and supplied it throughout Soviet Union, Ukraine, and as well in Germany, Potsdam, and Finland. So our background is just satellite laser ranging and a little bit related to optical systems for space applications that could be used for observation from space as multispectral optical systems and hyperspectral optical systems. Here you see one of our designed optical laser ranging, which is located in Riga. This satellite laser ranging has several advantages to other systems. It has very focused laser beam, which gives some additional advantages, and so that we can range smaller objects, smaller satellites, than others who use wider beams. We can detect object coordinates in real time, and so that, of course, we can range space debris, which has bad reflection, and we can. Our optical system is better than others because it can use different lasers. We can use different wavelengths lasers and different power lasers. And and as well we can use DPSS, diode pumped solid state lasers, which is better for free space optical communications. And all this system is smaller size that it makes it convenient for transportation. And there is one of our optical system which was designed for satellite, multispectral, very small size. And it has broad wavelengths, not only visible light, but as well into the shortwave infrared. And as you know, shortwave infrared gives several advantages for observation. And as well, we designed a hyperspectral optical system which has better some parameters. For example, optical power, better optical power, which is important for hyperspectral optical systems, because hyperspectral optical systems divide spectrum in many slices, and each of these wavelengths got very small optical power, and therefore the optical power is very important to have as big as possible. And second one, by the way, it has a very high optical resolution, which is again important. Usually all other optical systems for hyperspectral if they has good resolution in wavelengths, they has bad spatial resolution. So our optical system is both simultaneously optical resolutions. So we have in Riga some small workshops facilities suitable for our job, and that's all.
Thank you. Now we're entering the last subsection before the coffee break. It's dedicated to electronics. And in this section, the first to present Baltic Institute of Advanced Technology. And please be prepared, the RD Alpha Department of Microelectronics.
Hello everyone, hope you are not overloaded with such a lot of information. I'm Vytautas Rafanavičius from Baltic Institute of Advanced Technology. We are a private research organization, which means we are flexible and free of bureaucracy. We are aimed to high quality research, and our key technical facilities actually are outsourced, and we are using like artificial intelligence, Google Cloud, and something like that, because we need a rapid development of the technology, so it's not possible to do that with our facilities. We have ongoing projects in Horizon 2020, Ocean 2020, and also in PEX activity. In PEX, we are developing ultra-wideband radio frequency receiver front end. To our knowledge, there is no such receiver in the space industry which could cover Ka, Ku, X, and C bands on a single chip. So that's an ongoing project. We also have prepared the proposal for the transmitter that would make the transceiver, so the full system. Also, we are doing a lot in artificial intelligence. We are applying machine learning techniques for image analysis, and Other projects are like virtual reality and augmented reality for simulators. So basically that's all that we do, and it's not possible for one person to tell about everything. So maybe during the one-on-one meetings we can tell you a bit more. So thank you.
Sure. Thanks. 101 meetings will have 15-minute slots, including the logistics and moving from table to table, which means that you should, be done in about 10, 12 minutes, I would say. Like 2-3 times more the time allowed. All right, so now we have RD Alpha Department of Microelectronics, and the next one will be Testonica Lab.
Hello, ladies and gentlemen. Nice to see you. Such a big audience here. My name is Lev Lapkis, and I'm here to represent company RD Alpha Microelectronics. We has a very big history, like many of companies represented here. We were not born yesterday. We have more than 50 years of history, founded in 1962, those times state factory. Right now we are a completely private company. We are more than 60 persons, and our main experience is in the field of design and production of high reliability, right-hard and export-free components for European Union and other states. What we do, it's analog integrated circuits and analog to digital for aerospace, defense, and also special purpose microelectronics. So we are high reliability and red-hard triple E component producer. We have a full cycle production based here in Riga. We start from the designing of elements. We have our own radiation hardened library. We have flight history. Our parts flying for many years. We participate in very famous programs. Also participate in Soyuz programs. And right now we have participation in ESA programs. We are developing integrated circuit that could be possible for use in ESA missions. We started from a feasibility study because for us, European ESA market was new, and it was important to find what parts from our portfolio could fit ESA needs. We were working more than 4 years with Thales Alenia Space, with Airbus, and we started with feasibility study, and we identified that there is a big need in quad operational amplifiers and the quad comparators. We finished already development of quad operational amplifier of D124, and just yesterday I was notified by a PEX committee that our proposal was for qualification of developed integrated circuit was awarded, and we will be soon invited for contract negotiations. It's a big step for us, as we hope that we will be the first Baltic semiconductor producer that will be ECC certified. It's our goal that our part will be ECC certified, and it will be very easy for all players in Europe to buy and fly our parts. What our desired contracts? It's prime contractors, buyers of high rel and red-hard components, customers of custom design integrated circuits. So we have a full design. So we have designers of integrated circuits and a full production cycle. We can produce parts under your design, and if there is some need, some obsolete parts, we are working more in an obsolete market, obsolete microelectronics market, so we can substitute some producers that are not longer producing this part, but it's still needed. Research institution for common developments. We are a research and development company. We have some ideas where we need your help. What I also want to mention, this part developed under the PEX program, quad operational amplifier. It has 300 kRads radiation hardness. It's more than 3 times more than USA competitors can provide for you. So this part can be used for longer missions. And on the market, there is no such quad operational amplifier that can be used there. Also, have some time, I wanted to say that we are founders and members of Latvian Space Industry Association, and I invite all Latvian companies to join our organization, and in order to help our country to become a well-sustainable space country and become a full membership of European Space Agency. That's why we need to cooperate and help our government to take a right decision.
Thank you. And congratulations about the qualification. What is it, like small step for RD Alpha, big leap for the humanity? Oh, nice, nice. All right, Testonica Lab is the next one. Then Axon Cable Latvia, be prepared.
All right, good morning, everybody. And my name is Artur Ritman. I'm coming from Estonian company, Testonica Lab. Our company was established nearly 15 years ago, and we don't provide a wide scope of technologies, but during all these years, we've been concentrating on a very niche technologies, but we are standing out from the crowd in these technologies. And these are the FPGA instrumentation for test and troubleshooting of electronic products. And we're able to perform testing for stability issues, for signal integrity, for different defects, for manufacturing quality issues. And we have lots of customers around the globe which are using our technologies. And the strongest market segments today would be telecom for high-speed telecommunication, equipment testing, 5G base station testing, but also industrial electronics, which are using FPGAs as part of their products. And basically the geography embraces the whole world. And besides that, we're working on the systematic FDIR technologies. Sorry, all right. So that's for fault detection, isolation, and recovery during the in-field usage of the systems. And that has been a result of a long-term research activities in frames of different basically framework projects. And finally, today we are working on a ESA project, which is called On-Chip Health Monitoring and Fault Management for System Health Awareness in Space Missions. So the final demonstrator is expected to be ready in the summer this year, where we prove that we are able to run the operating system and run the tasks, run the software on a partially broken hardware. So imagine your microprocessor is faulty, partially broken, and it's not fully working, but still we're able to run the software on this microprocessor and make the system, the operating system, being aware of how healthy the microprocessor is, which resources could be still used. All right, so we continue working in these two fields, and we're looking for partners in the further research, in the advanced fault detection, isolation, and recovery technologies. And also, we're looking for customers, companies who are interested in testing for stability issues and defects in electronic products. Also, we are strong in FPGA development, FPGA programming. Also, we provide services for stability analysis or test strategy development for electronic assemblies. Thank you.
Thank you, Testonica Lab from Estonia. So now Axon Cable Latvia, and then our Lithuanian brothers from FEMTIKA.
So good morning. I am Alain Guénon. Should be Ineta should make the presentation, but she can't join today's conference and accept her apologize. Axon is a French group, and we are a subsidiary in Daugavpils. We are around 550 workers are working, and 10% of them are working for space application. And thanks for the three main actors, Thales, OHB, and Airbus, we are working for you in Daugavpils. What we are doing in Daugavpils? We do some harnessing, electric harnessing, and contact for aerospace. And aerospace, we do the pilot command, the electric pilot command for Airbus A350, all is assembly in Daugavpils. Also for defense and automotive. And we have also for OneWeb. We are working, the 800 satellites are assembly in Daugavpils for the electric wiring. We will realize in the next 2 years 800 satellites. For that, we have some workshop. We have an electric workshop, and we have also some plastic injection molding machine. X-ray inspection, CMM equipment, all to be able to be qualify our product internally. So what is the space market demand? The space market demand is weight saving. If we can win 1 kilo on the satellite, we can have more equipment inside. But also, we should have a good connection. Nobody can repair the wiring inside the satellite. So it is why we have a lot of qualification system. But to win weight, we miniaturize the connector. We was a sub-D connector, and we move now to micro-D, and we are on the way to qualify with ESA nano connector. So more and more the demand on the market is for satellite constellation. We talk about OneWeb, but we have also some other tender, and we are on the shortlist for the second one. So we also develop busbar technology for power distribution inside the satellite. We need between the panel solar and the battery to have the power distribution, and we do it by busbar. And we have almost all the satellite are our technology. So we use Bus 1553. That was the first use was for Ariane 5, and we developed this technology for some other technology inside the satellite, but also aircraft. So I don't come back on the weight saving. So we are in Daugavpils, and you are welcome to visit us. Thank you for your attention.
Thank you. Guys, just for the information, Daugavpils is not next door, but it's not that far away as well. It's like, I don't know, like 3 hours by car. Depends on a car. Good, good. Quite impressive. 500 people working for a company in Latvia. That's, in Latvia's scale, quite a big company, I would say. So, labas.
Hi.
Hey, I see you.
Labas.
Good, good. Femto now, and then we're going to close this session with Eventech.
Yeah. So, I'm Vidas Abraitis, and I'm representing our company Femto. And we are located in Kaunas, as you know, Lithuania. And we are providing ASIC design services for more than 10 years already, and mostly we are working for the companies in market areas of fiber optics and wireless communications, and for the companies which are providing testing and measurement equipment. Well, we cannot provide any special infrastructure for space, but what we can provide it is a team of experienced designers which are capable to provide services in ASIC, to provide services for ASIC design. And we are capable to cover full cycle of ASIC design, starting from specification and ending with silicon already. And we have a lot of experience while working with such technologies like CMOS up to 7 nanometers. And BiCMOS up to 130 nanometers. And currently we are starting to work on one ESA project. It is funded under PEX program, and it is a signal processing ASIC for synthetic aperture-based Earth observation instruments. And at the end of a project, we are targeting to have an ASIC capable to process 128 analog signals and cross-correlate them and integrate the data in the time. Another project what we have in mind that should be more than 10 gigasamples ADC. We're targeting to 6 or 8 gigasamples per second. And what we are looking for in this event, it is developers for synthetic aperture radiometers dedicated for Earth observation. And we are looking for the laboratories for the testing of ASICs. And what we don't have, or what is not so easy access, it is laboratories capable to test radiation hardness. So, and it would be great, of course, if that laboratory would be close to our location. And of course, we always are glad to provide ASIC design services. So if you are interested, so please contact us. So thanks.
Thank you. And now FEMTIKA.
So hello everyone, my name is Katrina, and I would like to ask for your attention during these last 10 minutes before the coffee break. I'm presenting event tech company, and we... So which one should I... okay. So we have been founded in 2011. And we're working in close cooperation with the Institute of Electronics and Computer Sciences in Latvia. We are licensed in technology from them, and we have been a success story in many cases. First of all, that we have been the first entity in Latvia to actually license the technology from an institution, and also, of course, to successfully commercialize it. Because we have reached technology leader level in satellite laser ranging, and we are covering more than 50% of the market of accurate event timers in that market. And we have also reached recognition by NASA, and you can see on their website for satellite laser ranging that our equipment is recommended for use. And also we have secured ESA contract in 2016 for the largest amount for hardware development in Latvia, and we have finalized it last week actually. So, and we're very happy about it because we started with two partners, the institute that we're working with and the Czech partner, but we finalized it already with a commercial partner. It's a company in UK, MDA UK, it's a Maxar company, and they're going to be using our technology in Luna 27 mission. And also we have sold 2 licenses in 2018 for their commercial mission application. And our current market areas that are of our high interest are space lidar technologies, drones, and altimetry, because we provide very high picosecond accuracy event measurement technology, and this can be used in all of these tasks, also for time transfer and synchronization, data transfer and deep space optical communications, and also for space communications. And picosecond accuracy provides for sub-centimeter spatial accuracy, also in space. Yeah, so our primary domain is time tagging and timing, because we can register time events not like a chronometer, but we can measure and register multiple time tags. And this is the uniqueness, and also, of course, high accuracy, and also that we can provide one-shot measurements. And the accuracy that you see is for these one-shot measurements. So it means that other technologies can also provide the same accuracy, but it will not happen with one-shot measurement, which is significantly important in space and in any other applications where the object you are making measurements for is moving, for instance. So currently, yes, we have reached our technology transfer to space grade level, and also are looking at other space applications apart from those mentioned. And we're looking at contacting everyone who is operating in the same domains, because we're open to partnerships, to partner within other projects, ESA or Horizon 2020, you can name it. And of course, we're looking at partnerships with primes and other big satellite system providers, and any other companies who have interest in our technology and see a way how we can develop it further. So please, if we don't have a meeting scheduled later in the day, you can just come up and we can discuss. Yeah, thank you.
Thank you. And of course, you were on time, since you're in timing business. Thanks for that. Good. Pretty amazing. I mean, on behalf of the organizers, thank you so much for sharing all the facts and achievements and projects and willingness to cooperate. I hope it will be worth it anyway. It's just the first contact. Then after the lunch break, you'll have one-on-one meetings to discuss more cooperation possibilities. So as you probably have noticed, we are ahead of the schedule, which means we are going to extend the coffee break a bit, quite a bit, I would say. But let's meet a bit earlier than the program says. I would say 11:15. Can we all do that? 11:15. Okay. I encourage you to not only drink coffee and, you know, do stuff related to coffee break, but also talk to people and get to know to at least one person you didn't know before. All right, see you at 11:15 back here. The coffee break is just in the same area where the reception desk was, okay?
All right, so thank you for being back. Almost full house, that's nice. Caffeine levels risen, right? Sugar levels back in normal, hopefully. If you didn't get any food, that's just fine. You know, anyway, you were sitting all day today. So, and we're having lunch break later on. So, same old principle, 5 minutes each. If you can manage in 3 or 4 minutes, wonderful. We all appreciate that. Before we start, we are going to have another one a bit, how to say, a presentation that is not that much in the scope of what we've seen before. But anyway, it would be very useful information for you guys. It's related to the science, what is it? Space Education Center, sorry, in Thales. Thales is a small town like 100 kilometers from here. A lovely place, highly suggested. And Pauls Irbins is from there and is really passionate about going into space himself or with the technology or both. Pauls, where are you? Oh, okay. So a few minutes from Pauls about this education center. And who knows, maybe you have some ideas to cooperate with Pauls.
Yes, thank you everyone. It's been, I appreciate for having a short break for us. I'm also president at Latvian Association of Space Industry, but I'm more known for actually doing space outreach and activities and working with kids to create the future space industry leaders. And I wanted to share this project that we're starting next year in Thales. This might be interesting for current space industry here in Baltics and maybe also in European Union, where we could collaborate. So we want to build a place that would motivate the future space industry leaders in European Union. We have 3 more important goals for this science center, a space-related science center that we're building. It's to increase in general science capital in society, to have a support for education system here in Baltics so that teachers can have more educational resources about space and so that students can learn about space industry in Europe. And of course, we want to promote space in general. Very shortly about history, we actually have been active in space education since 2011 when we started our small science center Zino in Cēsis. In 2012, we launched the first Latvian, we called the Space Pro, but it was actually a space balloon, stratospheric balloon, but nevertheless, we were the first ones to do it in Latvia. In 2013, we've been organizing the first Latvian Space Festival. In 2014, we had the first Latvian Space Camp organized in Cēsis. In 2015, you might remember there was a great European Space Expo exposition in Riga that we organized, and it had a second largest number of visitors in the European Union after the Greece, which we're really proud of. In 2016, we started organizing space race competitions for companies when they build their balloons. In 2017, we started building first Latvian sounding rockets, and we're still the leaders in this industry in Baltics. We build the most powerful sounding rockets here in Baltics. And in last year, we actually started a program to test if we can launch rockets from stratosphere. Again, mostly for educational purposes. We have already students working with us, and we see this is a great way how we promote space to schools and to children. Now, coming to our space education center that we're building, we basically have 5 general focus areas in terms of our content. It's a space history or space social sciences, cosmology, space technology, living in space, and healthcare. So these are the topics we want to focus on, just to show also for the society that space is not just about the rockets and astronauts, that we have different sciences involved in space, and children can find themselves in different space and STEM education sectors related to space. The building actually will be a very unique, because you've probably heard about the passive houses, but this will be a new concept called a living house, because the building itself will be like a big spaceship. We will have electricity generated from while walking on the floor. We'll have water reclamation from the air that you breathe out. We'll have rainwater used for toilets and many other actually technologies that they use in space, but we will actually can showcase how technologies that we use in a space station can actually be related to our everyday life. In terms of target groups, foremost, these will be families, school groups, teachers, university students, and also high school students. We have a pretty big territory planned for this center, almost 1 hectare with a lot of indoor and outdoor activities. We are very much in cooperation already now. Actually, we had 2 great working days yesterday with Narom Tandoja Space Center in Norway. You might know it. They're launching really big rockets. They just launched a huge rocket for NASA, which they're very proud of, but I had to mention it. Together with them, we see in terms of content that we offer, there will be a lot of interactive exhibitions. We would do a lot of space-related simulations for schools, for families. We would have our own Baltic Space Camp. We would organize concept competition. Actually, the first one we'll organize already this year, and then next year we'll have it a full national scale. We will have a great product that's called Space Mission in a Classroom that we'll do together with Norwegian guys. We will actually be building student rockets together with Riga, because we're also very closely working with Riga Technical University, and we will have their design factory within our Space Education Center, so that it will be not only for families but also for students to come during their study process and do different things. Yeah, of course there are going to be a lot of outreach activities, so that's it. 5 minutes. Thank you.
Perfect timing. Thank you, Pauls. Lovely that you have so much initiatives related to kids. My oldest daughter, she's 12, she had an assignment in the school to make a survey. And she said, well, you're going to undergo the survey. I say, okay. So there were questions like, what's your favorite color? What's your favorite food? And then she was like, what's your biggest life dream? Or like aim or goal? I was like, whoa, you know, the favorite food and then the life goals, you know? I was like, whoa, whoa. And I said, really? I want to go to the space. And she was like, oh, are you thinking of becoming an astronaut? Like at your age? You know, something like that. I said, no, I want to go there as a tourist. And I really hope that in my lifetime and in our lifetime, we can all go as tourists in space. Because I don't believe that the world is, you know, like round. I think it's flat anyway. Look at, I mean, living in Latvia, it's totally flat. You know, come on. All the pictures produced by NASA, not so sure. Cool. We're going to start our second session. Originally, there were 14 presentations planned. It's now 1 more, since we're so efficient with the time. So it's 15 presentations, different subsections. So the first section is satellite laser ranging and global navigation satellite systems. So Latvian University would be probably represented several times in this session, but I hope that the guys know in which section who is actually going to present. So Latvian University, or to be precise, the University of Latvia. And the next one would be from Estonia, Precision Navigation Systems. All right?
So, good day, everybody. So I will represent the University of Latvia regarding to SLR and GNSS navigation and etc. So what we are strong enough in what fields? As we are a university, we are higher education and research entity, which has almost 3,000 employees. So we have a long time experience in ground-based space observations, such as the GNSS, RTK, and post-processing reference networks establishment and testing. GNSS observation for land crust movement monitoring and several other things. As well, our experts have built several SLR stations, which is such as in Australia, also in Soviet Union, Germany, Finland, and also in Latvia. At the moment, we have 2 SLR stations, one of which is operated by Institute of Astronomy, and located on one bank of River Daugava, and which is already on duty, and another one is in calibration phase, which also is planned to launch in nearest future for observations. As well, we have a lot of GNSS equipment and also gravity meters, magnetometers. And also we have developed our own constructed digital Zenit camera, which is meant for mainly for geoid models. So, as already mentioned, the key technologies SLR observation, astrogeodetic instrumentation development, control and post-processing software development for astrogeodetic instruments, and also GNSS data analysis for UPOS Combination Center. As well, I am a UPOS vice chair for next 4 years period. We have several ongoing projects and also some projects in evaluation and some planned projects to submit to ESA and also our institution for funding. And here is the desired partners, suppliers, and also cooperation members, and as well customers who can be our customers. So you can read it down, and that's it. Yeah, I think I saved some time.
Nice. All right, thank you. Precision navigation systems. All right, and after them, Institute of Electronics and Computer Sciences.
Hi everyone. Cool. Hi everyone, my name is Simon. I'm CEO and co-founder of Precision Navigation Systems. We help drones, robots, any other GPS, Galileo, GLONASS equipped assets to navigate or to be positioned or tracked with up to 1 centimeter precision. So as my colleague just told you before about the stations, so this is the users of the stations that he talked about. So there are multiple applications of ground-based GNSS stations that correct signals that are coming from satellites, and this is some of the use cases that might be that might use this kind of technology in their work. As a good example, cadastral surveying and precision agriculture. How these stations look like this. So we used to build the stations our own, but right now we're focused on building software that helps the stations operate, gather data, post-processes, and deliver to users into the standard industry formats. What problem do we solve mainly? So there are thousands of the stations around Europe, around the United States, and users as well. But all these stations, they're owned by different parties. They're not interconnected. They have different softwares, hardwares, data formats, etc., etc. And for users, it's a problem when they're going from one region, basically from one station provider to some other region. They have a problem of finding the stations, make sure that it's working, connect to it, get the data. So we solve that problem with our project, which is named Hive. So we basically unify all this landscape by connecting all existing stations to our platform and deliver data to the users. These users are traditional ones. Right now we are focusing on more, I would say, sexy industries, which are last mile delivery robots, delivery drones, autonomous vehicles as well. It's still some time till they will arrive, but on some models like this one, you can see a small GNSS antenna. So they're also using the same technology. And like up to agricultural robots and e-scooters. So all of these applications, basically, they need positioning. They need to know where they are. And we can help them to do that. So here my goal is to, first of all, if you are dealing with drones, robots, any other assets that should be navigated, tracked, or equipped, or positioned, please talk to me. If you have a station or you know someone who has a station, let's talk about partnerships and business models, how we can help you monetize the assets that you already have. And third, if you are in a university and you're doing some crazy scientific stuff that can be applied on top of that, what we're doing, let's talk about partnership. Thank you. I'm Simon from Precision Navigation Systems.
Thank you, Simon. All right, now the Institute of Electronics and Computer Science.
Then after that, geometrics from Lithuania.
Hello everyone. I am not from technical science, my background in social science, so I hope I will be less technical describing what we are doing. And to speak with, I represent the Institute of Electronics and Computer Science. The Institute has been established in the 1960s and employs 80 people. Its main focus is signal processing and analysis of these signals received back. And today I will talk on three applications most closely related with space technologies. So the first one is our industrial partner Eventech just recently before coffee break explained a bit more about timers. I'm not going to repeat many things, but if we take background of that, there is a laser transmitting signal and recoding it back, so we can apply and measure ranges and doing that quite fastly. We are decreasing like signals and we are having higher measurement rates, which leads to higher precision. And if you see that, like they are quite bulky on size, and the next project we are working with is bringing the size down to the ability to put AutoNet on satellites. So in putting new applications so the satellites between themselves can measure times and distance. And if we put that back, so we are a research organization basically, and we are looking for anything which can build any application based on this laser transmitting and analysis back. One of the few applications you might see anything where you are measuring something. It's altimeters, this is LiDAR systems. And the new application might be also related to data transmission using laser signals. The second area would be like how you get wooden brick in the space. It happens when your communication channels are broken down. It's not pointing to the Earth. You are losing ability to communicate with the satellite at a particular time. There are a few reasons why you can come down to that. If you have just one antenna, it's too fast rotation, malfunctioning of the power or steering systems. And what we are designing currently is to having a bit ability to transmit from each of the side of satellite. So irrespective how the satellite is being positioned, it always transmitting the signal towards the point you are looking for. What it helps to have fixed points. It decreases need for power. You don't need to steer it always. And in the same point, if you have a base on the station, on the same base station, you can transmit more data. So you need smaller number of base stations on the Earth. So for large fleets, it's quite saving time of them and money. So this is like technically more what I described for. So if you know someone who is looking for that kind of applications, we will be very happy to speak on it. The last areas where I'm more involved myself is about how to make use of satellite imagery, which every day is being produced in terabytes, and the ability to read the data and analyze that makes a challenge. Here is what we do. We take an optical data, we apply an unsupervised algorithm, which been designed in the core quite differently from those which has been used in current GIS systems for last 50 years. And then we can arrive at classification what kind of land area we are having in particular type. And I will walk through some of the applications so we can apply to the tree species if you wanted to measure biomass or forest stocks. You can put that for the smart farming as for food to be grown. It's very important what kind of nitrogen levels you are having there. This is like comparison what algorithms find with the area with the on situation measurement in the same place. And this is like some things we are looking forward in future is how to aggregate climate measurements with the land cover, so we can also to find some which is low emissions emitters on the ground level. So this is like how far we have came also to the European level, and this is what anything you can looking for decision support systems in some of the industries. We will be very happy to speak. Thank you.
Thank you. All right, geometrics now, and then afterwards Institute for Environmental Solutions.
So hello, my name is Marius, and I'm here to represent the Geometrics company on behalf of Gediminas Vaitkus, which unfortunately couldn't attend today. So I'm going to try and do my best to give you a quick overview of what the company does. I forgot this one. So the company is a GMS Copernicus service provider, and has been such since 2011. Focuses on automated geoprocessing and data analysis, with the key market being the agriculture market. And within that, the company is mostly active in areas like the Common Agricultural Policy, or CAP, checks and control, and smart farming. Also the land use and land cover monitoring for state level and cross-border land management. The key product of the company is called Sagres. So Geometrics is a software company with its main competences being in automated parallel processing of optical and radar data. Its current space-related developments include the Sagres backend, which is comprised of pre-processing and statistical sampling, also digital mapping modules. And building on top of that is the CapCon and CosFarm front ends, which are subsequently used for smart farming and then the cap checks. The company is potentially interested in finding partners in developing the front end, so building on the Sagres backend and expanding the front ends like CapCon and CosFarm. It's also looking for an affordable data access service provider, and potential customers that the company would be interested in is anybody that would use the Sagres backend for their custom application. So the major stakeholders in the company right now is the public sector in Lithuania, and that includes the Ministry of Economy and Innovation, and that comes through informational sharing between different entities in Lithuania and abroad. Next one is the Ministry of Agriculture, which is using the software for the aforementioned cap checks. Following is the Ministry of Interior, which was interested in using Sagres for flood monitoring, and also the Ministry of Environment uses software for estimating water self-cleanup through natural basins. So this slide is a bit busy, but the most important points to take away from this is that the company uses both radar and optical data in its software pipeline. And I would say most emphasis is on the radar, just because you could get more information for a specific land area. As you can see in the top left corner, that's the Lithuanian map. And if you compare the radar data with the optical data, you get more in the radar spectrum per pixel compared to the optical in the order of magnitude. So moving to the right corner, this is just showcasing the sort of things that the software can do, and one of which is the dynamic mapping of land masses. and that is to classify the crops, so you can distinguish between beets, wheat, potatoes, and such pretty efficiently using machine learning algorithms. The next one is change detection in soil and vegetation, which is particularly useful for farmers to implement the smart farming, as they can see the changes as they happen in time series. Moving to the bottom, the aforementioned state institutions might be interested in using the software for detecting faulty drainage systems and potentially detection of crop damages, which are important for CAP checks and enforcement. You can find more information about the software, the whole pipeline, at cygrus.eu. Last slide, I have some time left. So this is basically showcasing the CapCon front end, and CapCon is able to classify the vegetation using such parameters like the volume, density, consistency, and maturity of the soil. And that uses specifically uses the GRD backscatter data, which I believe comes from the Sentinel. It's a Sentinel product. Yeah, so I think I mentioned everything.
Thank you.
Time.
Thanks.
Thank you.
We shall continue the subsection of Earth observation data, analytics and software. So the Institute for Environmental Solutions is happening now, and the next presentation is Klaipėda University.
Okay, hello. Thanks for the introduction. I'm representing Institute for Environmental Solutions from Latvia. And we are a privately established institute, which consists of multi-disciplinary team. Basically, we have both sides of expertise. So on one hand, we have these guys who has been called so-called rubber boots guys, who are not afraid to get dirty, and they're going to the field, and those are biologists, limnologists, forestry guys, etc. On the other hand, we have this technology part in our expertise, those guys who like to sit on another side of the screen and etc. And together we try to develop data-based environmental solutions where Earth observation is a tool how to get to the goal. And besides, our institute is located near Cēsis in the airfield, and we also operate quite sophisticated airborne flying laboratory, also using drones. Basically, we are using different kind of remote sensing techniques to achieve our goals. And talking about our applications or directions, thematics where we have experience, one of them is monitoring of grasslands. Within one of the PEX projects, we have developed workflow for classifying, for monitoring of grasslands, and also we touched some specific. We paid attention on quite interesting topics like detection of invasive species, particularly giant hogweed, which is a quite common problem not only in Latvia but also Estonia and Lithuania. And currently we are continuing this work in cooperation with grassland experts in different activities, mostly funded by LIFE projects, where we are responsible for monitoring activities and assessment activities of grasslands. Lakes is quite interesting thematics in our institute, because we have limnology department in our institute, which provides lake research as a service to local municipalities. And currently it is done by standard methods. They are going to the lake, making sampling and so on for making recommendations how to improve the status of the lake. And currently under ongoing PEX project, we are trying to add added value using Earth observation, and see how Earth observation can give added value to this service. Another topic what we are working on is related to rural spatial planning. In this particular case, it's also ongoing project feasibility study in cooperation with private company Forest Owners Consulting Center involving also local municipalities. We are using our experience in land cover classification, that also habitat modeling, trying to make a tool for rural spatial planning. And the last what I wanted to probably share is that besides such thematic activities, we are working quite close with end users, and from this cooperation with end users, we saw that something what is needed in Earth observation field is rising awareness among the end users, and this is also another activity which is financed under a PEX program, which is related to making training program for high-level managers. Sounds quite challenging, and it is. And but as you know, if you are not aiming like high, it will be hard to get significant impact, and it will be interesting what will come out of this. But we are aiming to give our input in uptake of Earth observation. And yes, these are just only some of activities what I showed, but we are also working in other thematics, also forestry and agriculture, and we are related to, quite closely related to end users. And if you are interested in some of our activities or in our institution by itself, you are welcome to come and talk later with me. Thank you.
Thank you. All right, the next is Klaipėda University. Klaipėda is a nice place in summer.
Yes, welcome.
It's windy in winter, don't go there. And then Baltic Satellite Services.
Hello, so my name is Diana Vaičiūtė. I'm from Klaipėda University, and today with my colleague Martinas Bučas, we are representing Marine Research Institute. This is the research and development unit at Klaipėda University for environmental sciences and maritime technologies within the Klaipėda University, with well-defined interdisciplinary directions and also international leadership. So why we are here, and from the space sector, we are dealing with Earth observation based downstream applications and services, supporting European Union directives. So also we are dealing with innovative monitoring, data management, IT and modeling technologies, also in situ research for natural resources and ecosystem services, and integrated spatial planning. So key infrastructure and technology and technological facilities. So we are computational IT facilities. Also, we have newly established research and development laboratories where we can do all the biogeochemical analysis, also for the Earth observation data validation, and also the field research facilities in order to collect in situ data for remote sensing data validation. So some pictures here, what we have in situ radiometry, and also we are working with aerial photogrammetry using the drones. Key technologies and competence in space sector, it's remote sensing data processing and modeling, also Earth observation based product calibration and validation. And at the moment we have two activities going in at Klaipėda University. We are part of the H2020 EOMORIS project, where we are building the downstream service for water quality assessment, monitoring and management. And we are within the international consortium, and this service is supposed to be brought to the to the market. And the second activity is under the PEX contract, is more dedicated for the national authorities, also for the private sector, to build the Lithuanian service for water management, mainly supporting the European directives, HELCOM activities, and the Baltic Sea activities that are under the ESA. So then the current and planned developments are Earth observation-based downstream services for the water management, so we are continuing with this activity. Then ecosystem status assessment and monitoring based on remote sensing data and ecological modeling, so the mapping of the natural resources, evaluation of ecosystem goods and services, and then operational monitoring and service for natural hazards like coastal erosion, floods, also the dryness, and specifically dedicated for the application of space products and technologies. Our partners that we would like to get into contact are research institutions that are working in the similar field, or for instance the companies that are building some sensors, because our strength is Earth observation based product validation and calibration, algorithm development, and also the building of the operational processing chain for the Earth observation data. Also the companies that are dealing with different remote sensing techniques, like airborne data, underwater system platforms, and so on. So, and at the moment we are very in contact with our local users, the governmental authorities, seaport, and also the private sector. So we are working with them closely together, fulfilling their needs, just providing the Earth observation-based services for them. So welcome to talk with you at any moment. Thank you.
Thank you. All right, Baltic Satellite Service. Yes, it's one service, it's not services. Just one service. All right, tell us about it. And the next one would be GIS Centras.
Yeah, okay. Baltic Satellite Service is a company which provides satellite imagery. Baltic Satellite Service is a company which provides satellite imagery analytics, and our background is basically geographical information systems, and therefore we are focusing on finding different applications which we can derive from the satellite imagery, and which can be beneficial for different industries and different businesses. Basically, we already have developed operational services, and one is Forest Radar change detection, which provides weekly alerts on fires, on clear cuts, on windfalls for forest owners, forest managers, and for the forest industry. And another service is which supports this Forest Radar change detection, which is based basically on Sentinel-1 data processing. Forest Radar cloud-free base map. It is based on Sentinel-2 data, which supports this Sentinel-1 data analysis and provides more clear and all this visual information. We have worked a lot with colors of the Sentinel-2 data. And we work also with large areas, so we cover like countries. For instance, now we have coverage of all Latvia and Estonia, and including archive. So we have worked a lot with automation, and therefore we are capable to provide large areas of interest over a very short time frame, and we are capable to provide these weekly alerts or weekly weekly updates of Sentinel-2 imagery as well, if it's available. So therefore, we are also in top of our services. We can provide infrastructure or ready prepared Sentinel-1 and Sentinel-2 data for everybody who is interested to build machine learning models. And in this case, for instance, you don't have to spend lots of time in doing pre-processing, post-processing of satellite imagery. You can just get the ready data and just focus on your machine learning model to get the best result out of this. We ourselves also use machine learning models and all this automation processing in order to provide these services to our forest customers already. What we are looking for is some IT or GIS companies which would be interested cooperate and maybe integrate our forest radar technology into existing systems to add value to their business customers with this information derived from satellite imagery. Forest radar is validated technology with many forest owners already, and they are happily using this unique field information for their everyday business activities. And in terms of customers, yes, we are looking for forest customers, large forest management companies, also private forest companies who would be interested to know actual situation in the field, what is going on with their forest property. Also, yes, we started to work with gas companies for change detection in their network area. And so we are developing service to monitor or illegal or some encroachment activities which are going on near the pipeline network. So, thank you.
Thanks. And now GIS Centras. You might guess it's from Lithuania. And then Datel from, any guesses? Estonia? Ah, there's Estonian guys. All right, good.
Okay. So hello everyone, I'm Andrius Balčiūnas, I'm from GIS Centras. So GIS Centras is state enterprise, it's working more than 25 years in GIS remote sensing fields. And both in governmental and also in business fields, sectors. So GIS Centras with more than 80 employees from different fields, from GIS, IT, and remote sensing fields, mostly dealing with national data updating. So we are managing and distribution national spatial data sets. Mostly it is topographical and on-the-ground data, but we are also providing and dealing with orthophoto imagery and satellite imagery, as well with the underground spatial data sets. And we are also maintainers of Lithuanian Spatial Data Portal. It's a National Spatial Data Infrastructure Portal. And we're providing all these data and other institutional data through this portal. And as well, we are developing or managing the developing projects of large national informational systems. And also, we are developing the integrational applications and services which integrate this huge amount of data we are storing in our national geoportal to our national informational system or business applications. So a few years ago we actively started working, researching and developing in the fields of Earth observation. And last year we successfully finished the PEX project, and the result of this project is 3 national, constantly updating and cloudless RGB and DVI and near mapping services, and also geoprocessing service for calculating NDVI index on the fly. And these services are already integrated in our national geoportal, as well as these services are in the road to be integrated in 2 more informational systems. So we have really big plans for the future to create, from these results, to create monitoring services. These services to monitor crops and to allow national informational systems to get access on the fly to these monitoring results. So we are preparing the new PEX project for that. And in this event, we are looking forward to find a partner for accessing more EU Earth observation data on the fly for our governmental partners. As well, we are looking forward to cooperate in our national projects in the fields of spatial data or Earth observation data processing and acquisition. So just meet us everywhere. So thanks.
First one being Datel and then CGI ST.
Hello, my name is Andreas Kiik. I'm the Space Program Manager in AS Datel. Datel was founded in 1990 when it was almost illegal to start a company. We have the flexibility to stay in competition, find new business opportunities, adapt to the changing market needs for over 28 years. Our main business directions are software development, IT infrastructure, and presentation technologies. So we offer the client the full solution. We have customers from 3 continents and deploy more than 100 highly skilled professionals. Our offices are located in Tallinn, Estonia, and in the state of Virginia in the United States. This gives us an edge to make business with US companies and government. Datel has made life easier and more convenient for many Estonians by creating numerous e-state backbone services. Some of these are land cadastre, address management, national statistics, flight safety, road maintenance and survey, Estonian tourism, and many more. Our clients have won several prizes in the US and in Europe, which means our solutions are innovative and with high quality. Our advanced technological experience and wide partner network helps us to solve almost any problem that arises with new or existing clients or new market opportunities. For example, in Earth observation. We combine both open source and commercial software to maintain high flexibility and security. In the core technologies, we have more than 20 years of experience and have successfully delivered over 100 big projects. With the changing world, new businesses, and technology, our focus is in radar remote sensing, in which we are working closely with our clients and partners to create the global value chain. Datel has an R&D cooperation agreement with ESA, contributing to develop our new early warning system called SILLE, which enables to detect and monitor deformation everywhere in the world. SILLE helps to foresee accidents and reduce threats to the general safety of the society. SILLE has been built in collaboration with scientists and partners from Estonia, USA, Italy, Germany, Australia, and Spain. We are looking for further cooperation to solve difficult problems and offer higher value to critical service providers. Datel has made life easier and more convenient in the past 27 years for many Estonians, and now we are doing the same for everyone in the world. Thank you for your attention, and see you later at the meetings.
Thank you. Life being made easier. That sounds really promising. Thank you. All right, CGI ST now, and then Lithuanian LSIs Pro.
Hi, good morning. My name is Karel Hansen. I am the manager of space business in CGI Estonia. So Eesti means Estonia in Estonian. I'm here with my colleague Martin Jussi, who is the head of Earth observation area, business area, and we will be together at the B2B meetings later. So, CGI Estonia is an IT service and business consulting company, part of the global CGI group. We have more than 25 years of experience in software engineering and business consulting and delivering high-end IT solutions. We have been active in the space business more than 8 years. Our business started with collaboration with other CGI units, mainly UK and Germany. And together with them, and not just with them alone as well, we have delivered solutions in ground segment and Earth observation domain to the European Space Agency, EUMETSAT, and local clients. In the current context, I have only noted down 2 key current market areas, which are space and public markets. However, within CGI, we also deliver solutions to energy, utilities, and telecom areas. As we are a software engineering company, our key competence lies within software engineering. We have experience in various development platforms and technologies. Talking about space, our main experience lies in mission data systems, monitoring and control, mission planning, and other data systems, including data archival. So currently we have an ongoing contract with ESA in the area of mission planning, where we develop a proof of concept solution for ESA's mission planning system framework for mission operations framework, which is a CCSDS standard. Also, we work in Earth observation. We develop Earth observation processing services, and in this area we also have had a contract with the European Space Agency, which was called the Interactive Hosted EO Processing, where we developed a proof of concept solution to try out if graphical processing units speed up the processing of Earth observation imagery, especially SAR imagery, which is, who knows, it's quite a lot of data, and the processing takes quite a while. So we proved that it really speeds up the processing, but it depends on the actual algorithms behind it. Science operations configuration control infrastructure is an end-to-end system engineering platform that's currently in use in ESAC. And also, we plan on working more on mission planning and scheduling services. So desired contacts that we'd like to find. First, a partner to work on Earth observation area, especially an image provider. It can be a satellite operator. And customers. So as I mentioned, we are an IT company. We can provide software engineering support with domain knowledge in the areas of mission planning, monitoring and control, data archival or general software solution development, and EO services and solutions. And also, we're looking for an entity requiring EO imagery, processing services, especially for products consisting of long time series and fast processing speed. So we can talk more about this later in the B2B meetings. Thank you.
Thank you. Going good? Ahead of schedule again. Nice. You know. 5 more presentations to go in this session before the lunch break. And the next one is LSIs Pro, and after them, Pro Expert.
Hi, my name is Peter.
I am the strategic key account manager for LSIs. It's a Lithuanian company, but I am in fact Danish in our office in Vilnius. LSIs is the largest defense company in Lithuania. And we are fastly growing also in the air traffic business, where we try to deal with European congestion in the air traffic. I'm sure already now you feel when you travel through Frankfurt, the endless delays of aircrafts in and out of that airport. It's only going to get much worse. We are the main system integrator in Lithuania for defense, for infrastructure, energy, and so on. But on the European market, in our international market, we are a very experienced prime and consortium member on European Defense Agency programs. We are a very professional subcontractor on large NATO and national command and control intelligence systems. We work with the largest of the system integrators, and if I can just start from here, we are a key industrial partner to Thales. We have done several projects with Leonardo and Alenia. Airbus, we've been good friends for the past 10 years, hundreds of thousands of R&D hours in the NATO Alliance ground surveillance program. For these partners here, these big system integrators, we also help them innovate. Of course, we provide scalability in form of a bit of outsourcing, but what we really appreciate is doing innovation sprints, trying to get them and their ideas out in the opening, and we are quite good at making something from an idea into a prototype. That also brings us to the US market, where we are engaged with the US agencies on these innovation programs, and that is creating a lot of traction in this area. You say that, some people say that space is the final frontier. For us, space is just the next frontier. And we have, through the past year, engaged in several interesting space-related application projects. In the US, for Homeland Security, we are trying to identify black vessels through RF technology from nanosatellites. We are very much looking forward to Iridium's space-based ADS-B signals, trying to create more intelligent flight planning in the European market. And one other thing with our flagship is that we have promised our defense agency that we can deliver a prototype of our Earth observation camera that is 3 times better than the best standard right now at 1,000th of this price. So space is really the next step for us. And the next thing we particularly look at is a project. Let's see if I can get this up morning. It's about constellation management. There's going to be thousands of nanosatellites and also larger satellites in orbit. But how are you going to manage this massive amount of assets in a complex environment of radio signals and data and whatever that comes through here? And we are trying to establish a project, and we are looking for also consortium partners that want to see if we can establish some kind of, from our point of view, a data bus based on our experience from defense IoT that can manage this constellation through, for example, the massive amount of latency you will be experiencing. This will be done by having these nanosatellites that are, of course, orbiting rapidly around the globe, passing ground stations once in a while, and they will continuously be intelligently told who is the relay station for the ground station, and by that creating an intelligent, dynamic network across around the globe. It's based on a technology called Data Distribution Service developed by Thales and a few Americans for the defense industry, where you also have massive amount of complex networks where you have drones coming into your network, leaving the network, soldiers coming in and out again. And we think that this technology can also be used in the space domain. I can just come with a quick example for some here, and this is for the software architects here. They should be happy to see something like this. For example, it's an airplane that passes underneath a nanosatellite. It sends out an ADS-B signal, so a location signal, up to the nanosatellite, but the satellite is not nearby. It is not the nearest to a ground station. It decides instead to relay this message to the neighboring nanosatellite that is closest to the ground station, and that signal comes down. The software should do so that it should even intelligently say that maybe you should split the signal, and so half of the signal goes one way, the other half goes the other way, all in terms of optimizing latency and bandwidth in the network. this is one of the many ideas that we have and is moving into space. I have a few meetings with you guys at the B2B meetings. If you also want to talk through in lunch, feel free to come by. Let's share some ideas. Okay, thank you very much.
Thank you. Just make sure you pick a bigger table than you know, because I think a lot of people would want to have lunch with you. I hope. Okay, to conclude the subsection of Earth observation, pro expert, and then we will hear from cybersecurity guys. Guard time.
Hello, my name is Henry Island. I'm coming from company ProExpert from Estonia. I don't show you too much slides. I'll tell you a bit story. ProExpert has been involved in software development and embedded software for 25 years. And we've been doing mission critical software for different companies globally. When it comes to the software, then we've been doing also software for end-to-end solution to different companies. When we're doing this software, then what we have learned that the companies don't ask the question very often why they're doing the software and what is the purpose. So when doing the software to the customers, we started to ask this question from them, and we came to, well, one reason is that we have 200 engineers and they don't want to do the software which doesn't be applied to somewhere where it becomes stays on the shelf. So we asked the question about that, why are doing the software for that particular application, and the customers realized that yes, that's something which is a good question and which we haven't asked in thoroughly. And this is a place where we arrived at working together with customers as strategic partners when developing service design and product design solutions, which means that we go through together with the customers exactly what is the use case, what is the business case, and also we go through the actual application of this. Then we do small trials, experiments. You can call it minimal viable product. And then once it has been proved on the market that it really works, then we launch it in large scale. So this is one part of our software development today. The other part which we realized together with customers was that either it's production company or some custom information, what they are receiving or having in the databases is that they either save the data, or sometimes they even don't have the data. So particularly with our production customers, we ask again the question that why are you gathering data, or do you gather data at all? And then very often the answer was that no, we don't do the gathering of data, or we don't use it at all. Yes. So there came in for us data science and machine learning exercises. So we approached our customers with the idea that let's gather data, let's try to figure out what does it mean. Maybe we can use machine learning, maybe we can use build some patterns which improves your production efficiency, or helps find out the fault products, for example. So we have a couple of good examples from that in electronics industry. So they had exactly the situation like that they did have machines sometimes were gathering data or sometimes not. So we put together the data from different machines, made connections, built patterns, and we managed to get to a new level for these particular production machines. So it's now integrated machines. For one particular use case, we managed to find the gaps in the production and bottlenecks, and as a result we increased efficiency for 2%, which is a substantial amount of money for them, because they're making 300 million of revenue. In the other case, it was the default product, which we can actually manage to figure out that based on the parameters from the machines and from the product, that not to let out from the factory the production which is default and which comes back to the factory. So these are the couple of examples from how we are approaching today our solution. We're doing the software, analyzing together with customer the actual business case, the use case, applying it together, and then also doing after-sales service. Thank you.
Thank you. Now it's time for cybersecurity subsection. Only one player in this subsection, guard time. Yes. Afterwards, some words about satellite communications from Ventspils University College.
Okay. Okay. Good day, everybody. I am Priit Anton, Program Manager of GuardTime, and my job is business development in space sector, meaning the business and also the innovation part of space activities related to GuardTime. About GuardTime, GuardTime is an Estonian cybersecurity and blockchain company with 170 employees and 8 offices around the world. When we were established in 2007, our first job was to help Estonian government to secure their e-government and e-services from potential cyber attacks. Mainly, the challenge was that when the cyber attack was over, there was the question, can we trust the critical registries that are being under attack, and then what should be done after the attack? We were successful in this, so from 2010, GuardTime technology stack is being used in a government critical registries side. So we are active besides the government sector, also in the defense sector that has a lot of security concerns, and also in the insurance and healthcare sector. The medical records are quite important, and whenever you have someone handling them, then you have to have potential to audit and provide additional means of security on top of these solutions. GuardTime is owner of the KSI blockchain technology stack and also Black Lantern infrastructure, that is a military-grade anti-tamper hardware used for additional security. So our core technology KSI is KSI blockchain that is meant to be built new innovation solutions based on blockchain technology, including cybersecurity and focusing on the integrity of data. This technology stack should be used close proximity to the existing platforms and technology with a minimal investment into the integration and workload cost. So this is very convenient for the space sector that has already quite a complex, sophisticated systems in place. So from the customer perspective, the technology is used so that you are getting an access in a global way to massive scale integrity verification of your digital assets. And by digital assets, we mean like the security logs, the documents, the files, the images from Earth observation data, or any other digital assets that you are basing your business on top of. Another area where GuardTime is active is in cyber sector. So GuardTime Cyber is working to assess the critical parts of cyber threats and planning the cyber operations and actually running the cyber exercises for our partners. And besides the exercises, Gardet Cyber is also developing new components for the cyber ranges for next generation cyber range and potential cyber threat. And keeping in mind that you have to be very efficient and modular to build all these complex scenarios for any kind of potential malicious activities. So in space sector, we are currently doing a joint project with ESA in the Copernicus core ground segment. So this means that we are looking to use the same kind of solution that we have for the critical registry for the government, also for the core ground segment Copernicus long-term archive. So everyone that is using the Copernicus data should be provided sort of new form of metadata that you can have together with the Copernicus images that can provide you the input of where the data came from, at what time, and also some proof of the processing chain before it enters into your system. So this is a very ambitious goal, and then we try to see if this is possible to solve in next 6 months, and also are interested to elaborate about this in the commercial satellite providers and then next generation satellite production as well. Thank you. That's all from my side, and hope to see you during the lunchtime and discuss.
All right, thank you. All right, 2 more presentations. Now Ventspils University College and then Solid State Physics Institute.
Hello everyone, ladies and gentlemen. My name is Romas Pauliks. I'm representing Ventspils University College, especially its electronic and satellite technology department. What is the key background of our department is the satellite communication subsystems. The primary, we are not only doing the research work, but also development. The development is especially unique. It's a satellite communication subsystem. It's a communication model for nanosatellites. Why it's unique? The unique, that's mean normally in the nanosatellite communication, the speed, it's around 10-20 kilobits per second. This our module planning launch the next year as payload module in S-Cube satellite, and the speed it's around the 20 till the 50 megabits per second in bidirectional communications. The next one background is ground station services. It's planned in the future. We are planning to develop all these new directions. What do we have? We have the quite unique infrastructure. We have the big dishes. It's a RT telescope 16-meter dishes, and the one what is not mentioned here is a 32-meter dishes, very usable for deep space missions, for many like SN and so on operations. What does it mean? The ground station services. The ground station service is a control facility service like a data storage, data processing, network operation control centers, and so on. What is mentioned before, that means we are operating the 2 main directions. The first one is the satellite communication subsystem, especially its communication subsystem. That means the communication between the ground station services and the satellite communication module, bidirectionally. The key infrastructure I mentioned before, we have the few telescopes. Probably in the future we also build the new one, RT 12 meters, only usable for communications, not only for radio astronomy or sharing radio astronomy and communications, but directionally for communications. What is the key technologies and the competencies? What we are doing? We're developing the radio frequency PCBAs and antennas design and layout, and of course using FPGAs, VHDL programming, like a GNU Radio, Python, C, and so on. That means in some partly the hardware and programming development in this area. About the desired contacts and partners, right now we have not in the satellite communications, but in other directions like a test and measurement equipment. We have the partners from Cryogenic and vacuum systems, and also from Latvian Koksnes and Ķīmijas institutes. Yeah, it's the partners here. Yeah. Not in satellite communications, but like a test and measurement equipment. That means we also produce some equipment in electronics, like testing from the sensors and measuring and calculate the data and you know, like in this way. It's all team. It's like a quite small, yeah, but it's very powerful. And then it's electronic and satellite divisions, yeah. And the main goal for us is 2 directions, so as I mentioned before, yeah. That means satellite communication subsystems in telecommunications. That means we are take the main thing from the regular communications from the ground and put in the space in some things with some like competencies and so on. Yeah, thank you for your attention. I try to be short and that's it.
Thank you. And the final presentation from Solid State Physics Institute.
Yes. Hello, my name is Andris Anspoks. I represent here a hub which connects together the industry and academia. And this is, I think, an interesting story. I hope the presentation will come on. Yeah, just a second. So what is the problem there? The problem there usually is that we need a clear business style communication, which is sometimes becomes very turbulent when industry meets an academical person, professor, in a direct way. We have easily found out that we need some kind of unit between them. And this is the story I will tell you. And when the presentation will come up, I hope it will happen one day. It's coming. Not at all, yeah? Maybe I should continue? Yeah? Okay. So, besides the clear communication, it's based on our competence. Our competence is lying into 2 fields. One is smart materials, and other is use smart materials in photonics, sensorics, and other fields. So this competence has 40 years history. And this history starts also in a good cooperation with space industries. It was a different time that time, you know. We were about the radiation protection, radiation resistance of materials like spaceship illuminators, like electronics and other things. So this is one part of the history, and today we transform this into new materials for different applications. So this is what I told you. This is a platform between industry and academia. And this is about our 40 years history of our competence, which is based on smart materials, materials in all other sectors, starting from energy harvesting and ending to photonics, and also including theoretical modeling and thin film technologies. And what service we provide? We provide single point of contact, as well as environment for developing innovations, including upscaling. So you must ask, if we are based on the Institute of Solid State Physics, how we can upscale? That's an industry. That's a good point. So this we do because we partner with our industry, with our high-tech industry, and believe me, you've seen something about the fiber optics. Believe me, there is a lot more fiber optics in this country called Latvia, because there are 2 companies like Light Guide Optics and Serum Optic, which are producing custom-based fiber optic products for power delivery and for wide, broadband delivery of single photons back and forth. Also, we have a thin film cluster here, starting from production facility of coatings and thin films, ending to the users which use these technologies to provide the anti-reflective glasses, including glasses on the acryl, which is interesting for the space applications as well. So also from the environment of our innovation development, we have some outcomes which are going to the market. One is infrared sensor, which is, I think, very interesting. If you look on the parameters, 1 square centimeter with such a speed is not a common thing. So it combines speed and sensitivity in infrared region. Actually, in any region, but in infrared, that is specifically interesting. Other thing is adaptive optics. So, as I said, we do photonics. So this is an interesting side effect. We also work currently on commercialization of new scheme for adaptive optics, not traditional way. Also, I think very interesting for space applications. And just an example, we are also in OLED business. We are creating a new kind of OLED device based on our materials and materials of our partners. These are 3 examples I want to show you. And what we look for cooperation with industry, industrial contracts, cooperation contracts. These are the things why we are here and ready to discuss. Thank you.
Break, and I'll give you technical details about what happens afterwards. You wanted to... Not anymore? Okay, we cancel this one. All right. Thank you for presentations, and that's it for today for the presentations, but you know that you have the plan of meeting people and actually talking to them one-on-one, or, you know, at least in the smaller groups. So, do you have your own schedules for your institution, the meeting agenda? You've received those things in email. If you don't have them with you, that's just fine. You can get at the reception desk. So that's important so that you can easily follow the schedule, which could be quite sophisticated, right? So after the lunch break, there would be, I think, yeah, 4 separate rooms. 3 rooms for companies. You will see them in the hall. There are signs on the doors. And then this big room would be redecorated. This wall will go away. You will have tables for one-on-one meetings. All right? So each slot for the meetings is 15 minutes, as I mentioned in the morning today. But of course, you have to take into account the time you need to move from the table to table. So basically, you should focus on having, let's say, 10 minutes a meeting. ESA would also help you with this process. Here in this bigger room, you'll have after the lunch break, and they will have their own table, number 0. Why 0? Like, it's just, it's like a, you know, yeah, no reason. Anyway, it's a help desk. So if you're lost, you just go to ESA guys and ask for the help. So, the meeting started at 2 p.m., which means it would be nice if you would be here like 5 to 2. All right, 5 minutes before 2. And that's it from my side. Lunch happens the exact same area where we had the coffee break. See you at 5 minutes to 2. All right? Cheers.